Halo,
Ya, baik.
halo.
Kong.
Oke, Pak Eko.
Ya, halo Pak Eko. Sudah terdengar, Pak?
Tes, Bli. Siap, Bli.
Ini sehat, Pak. Baru selesai, Pak.
Partner.
Iya, Pak.
Saya, Pak, for my main duty just
Siap, Pak. Siap.
opening this event and then that's all, Pak ya.
Iya.
Gitu.
Iya, Pak.
Then, you will present your paper.
Iya.
It's okay. How long is it?
It's about 30 minutes, I think.
30 minutes. And then
Yeah, I'll join you.
the next we can have a meeting for
Yeah.
the what you call Kilaying.
Yeah.
It's okay.
Yeah, Pak.
Where is the venue?
But in your office is okay, Pak.
It's okay. It's in the meeting room, yeah. It's okay.
Okay.
Thanks.
Iya, Pak.
They prepare for this occasion, Pak.
Iya. Is it okay, Pak? 24.
Okay.
For you,
I mean, for me,
Yeah.
it's okay.
So your graduation, your son graduation day.
I don't know. I don't know. In the next 24th, okay? I don't know.
Bu Kiki diundang ke wisuda aja dulu, Pak.
Oh, no, it's impossible. Yeah. At least I can catch up the photo session.
Okay.
Yeah, the photo session would be
Yeah, after lunch.
at 2:30
Okay.
p.m. Is it
Yeah.
possible we can terminate terminate Kilaying at 12? Is it possible, Pak?
Yeah, I think so, Pak. We already finished at that time.
Yeah, but it's not possible. The car bring me from Lamongan to PPNS.
We'll,
Just 2.5 hours.
we'll rent helikopter ya, Pak.
Difficult, Pak. Oh, it's okay. We can arrange later.
Yeah.
Oh, stop. Hey, Bu Reti. Oh, there are so many interesting memory, Pak. These photos.
Yeah.
Leo.
2022.
Pak Eko, we are going to start.
Halo,
Ya,
Pak.
ya Pak Eko, we are going to start after this, Pak.
MC itu pasti ke podcast. Iya, pasti. Please check your connection. Coba.
Nggak juga Kak.
Ladies and gentlemen, today's International Student Conference or ISC 2022 is going to begin shortly. Please make sure your camera is already open and turn your microphone off. Thank you. Assalamualaikum warahmatullahi wabarakatuh. A very good afternoon to distinguished delegates, ladies and gentlemen. Welcome to International Student Conference or ISC 2022. The conference is aimed to present and provide knowledge and perspective from students regarding the global issue and their research on maritime technology and any related fields. ISC 2022 is hosted by Politeknik Perkapalan Negeri Surabaya or PPNS Indonesia and co-partner from University of Strathclyde, UK. Ladies and gentlemen, it is an honor to me to introduce and welcome our distinguished guests at our event today. Director of Politeknik Perkapalan Negeri Surabaya Insinyur Eko Julianto, MSc Raina, Vice Director from Politeknik Perkapalan Negeri Surabaya, our keynote speakers, Professor Mehmet Atlar from University of Strathclyde, and Iputu Artawibawa PhD from Politeknik Perkapalan Negeri Surabaya, Vice President of Raina Asian Region, Professor Iketut Arya Priya Utama, Chief Technical Advisor UK Skill for Prosperity Program Indonesia ILO American, National Project Officer from ILO Jakarta, Ibu Dede Sinta Sudono, Lecturer of PPNS and University of Strathclyde, Glasgow, all delegates, ladies and gentlemen. This International Student Conference 2022 holds a theme enhancing the sustainable use of ocean-based research through innovation on maritime technology. The purpose of the conference is to invite students both from PPNS and University of Strathclyde to share ideas in maritime technology and other related fields. This conference is one of the activities in UK Maritime Skill for Prosperity Program supported by British Embassy and International Labour Organization or ILO Indonesia. And we are glad to inform you that this conference is the first international student conference organized by PPNS, especially by PPNS students. The conference will present 15 papers with 10 papers from PPNS and 5 papers from University of Strathclyde. We encourage you to actively join the session since the committee prepared the many rewards for the best presenter and also active participants. Ladies and gentlemen, for a brief moment, we would like to invite you to sing an Indonesian national anthem, Indonesia Raya. Thank you. Ladies and gentlemen, the first agenda is the speech from Director of Politeknik Perkapalan Negeri Surabaya, Bapak Insinyur Eko Julianto MSc Raina. Time is yours.
Okay, thank you. The Honorable keynote speakers, Professor Mehmet Atlar, University of Strathclyde, Glasgow, UK, and Bapak Ibu Duarte Wibawa, PhD, Politeknik Perkapalan Negeri Surabaya, Indonesia, and Professor Iketut Arya Priyautama, the Vice President of Raina, Asian region from ITS Surabaya, Indonesia, and Ibu Dede Sudono, National Project Officer from ILO, Jakarta. Distinguished guests, ladies and gentlemen, welcome to the International Student Conference, ISG 2022. It's the first conference for international students hosted by Politeknik Perkapalan Surabaya, or PPNS, in collaboration with the University of Strathclyde, Glasgow, UK, to reach international participants. It's a great opportunity for our institution, PPNS, to have all of you. ISG 2022 aims to bring new perspectives among local and international students, encourage students to present and provide knowledge about their perspective regarding the global issues and their current research finding in maritime technology and other related fields. Hence, this conference is expected to increase understanding about the problems and challenges in ensuring the sustainability of ocean-based resources. It's also expected that PPNS students and UOS students to meet each other and share their thoughts, knowledge, and ideas regarding the maritime technology and its application. Ladies and gentlemen, Politeknik Perkapalan Surabaya, as a vocational higher education that totally focuses on the maritime sectors, puts high priorities to enhance its role in enhancing any applied research, innovation, and invention related to maritime sectors and its supporting industries. Based on these missions, PPNS collaborates with the Royal Institution of Naval Architects, or RINA, and supported by International Labour Organization and the UK Maritime Skill for Prosperity Project, conduct the International Student Conference, or ISC 2022. This conference is one of the contributions of PPNS to facilitate the students to present their research findings related to problems, challenges, and innovations in maritime technology to maintain the sustainable use of sea-based resources. Ladies and gentlemen, I would like to take this opportunity to express my sincere appreciation to all of you, all keynote speakers, authors, and presenters, and all participants of ISC 2022 for their contribution in this conference. Finally, I do believe that through this International Student Conference, we can share our thoughts and ideas and research interests. And at the same time, we can initiate any possibilities to build strong collaboration in research internationally, so it can support the development of sustainable maritime sectors in the world. Last but not least, I congratulate you for your commitment and active participation and wish you all the success. Thank you for your attention.
Thank you. Okay, ladies and gentlemen, now is the time to photo session. Without any further ado, please open your camera and we'll take a photo together. And for the operator, maybe you can take a screenshot of us. Okay, let me count down to take the best pose of ours. 3, 2, 1. Say cheese. Okay, maybe we can take another one and the last one. 3, 2, 1. Cheese. Thank you. Ladies and gentlemen, allow us to play our special video for a moment. Please present the video.
Mulai lah. Iya,
Ladies and gentlemen, in this special conference, now we have our honorable speakers. Please welcome Professor Mehmet Atlar. Okay, we are now moving to our conference to the next agenda. That is to hear the keynote speakers. This session will be moderated by Dr. Priyambodo Nur Ardi Nugroho. Please give a warm applause for the keynote speaker session.
Good afternoon, everyone. Professor Mehmet, thank you for joining this conference. It's an honor for me to become the chairman or moderator of the session. On this exceptional occasion, Professor Mehmet Atlar would like to present his research entitled Bernica Replacement Project, Design and Operation Experience.
Thank you very much. Thank you very much, Priyambodo. Can you hear me? First of all, if my connection is okay? Somebody showed me by hand. Okay, thank you. Okay, good morning. Well, from UK time, it's morning here, and good morning to everybody. But I know that we are in the late time, so thank you very much inviting me for this presentation. And this presentation is going to be my if you like, past experiences, but still a live experience, which I will go through. And I actually involved in a research vessel design when I was in the Newcastle University. Please let me remind you that although I work for Strathclyde University at the moment in Scotland, in Glasgow, I used to work for Newcastle University in England almost 20 years. So therefore, I had a lot of experiences over there. The research vessel design history goes back to Newcastle University. So therefore, my presentation will be associated with this work. And let me put and share this and then talk about it. Okay, I'm sharing my screen now. Okay. Let me bring my, okay. I hope you can see my presentation now. The title of my, thank you. The title is Bernicia. That was actually the vessel. Let me also get my pointer, right? Pointer, here we go. This ship here at the background is called Bernicia. This was the old research vessel of so-called Newcastle University. And then we decided to replace this vessel. So therefore, it's a replacement project. Then I'm just going to go through with you my design and operational experiences. Later on, we called this vessel the Princess Royal, and why we called it Princess Royal, you will see later on with surprise. Okay. First of all, as I mentioned to you, the university had this so-called monohull research vessel. And then this vessel reached its end, almost 40 odd years. So therefore, we decided to replace this vessel. And then we thought that, I think, instead of having this monohull, slow going, you know, is really old fishing vessel, modified research vessel, we decided to maybe to go something like a modern catamaran. So what will this state-of-the-art catamaran? That was depending on our, if you like, enthusiasm. This vessel, by the way, it was built in 1970s. By that time, by the way, my experiences goes back to 2011, 2012. So the research vessel was designed and manufactured 2012. As I mentioned to you, this is an old experience, but it's very interesting. That's what I wanted to share with you. So anyway, by that time, 2012, this vessel, as you can see, that's 1973, almost 40, 50 years old vessel. It was 16-meter long, and she was very, very heavy lady. It was almost 60 tons, and she could only go 9 knots. So that was very, very slow. So it wasn't an exciting vessel. But it can do all kind of so-called multi-purpose research, like she could do conventional trawling, and she could do fishing using static equipment, sediment sampling, plankton sampling, water sampling, rock dredging, seafloor coring, etc. As you can see, these are all related to marine science research, because this vessel belongs to marine science technology, whereas myself, I was in the marine technology, i.e. I was an engineer, and then marine science was scientist. So, but in those years, Newcastle University decided to amalgamate, to bring together science and technology, rather than having 2 different departments. They said that, okay, let's have a school of marine science and technology. So we came together. When we came together, I was interested in this vessel. I all the time go on board and then talk to its captain, its skipper. One day I told him that, Alistair, this vessel is so old, this is nothing. Why don't you have a nice and modern vessel? She always used to tell me, Professor Atlar, I love to have one, but we need money. We need enthusiasm and so on. I told him that let's do it. Let's do it together. How we're going to do that, I will explain to you. Of course, that before amalgamated, marine science always had a research vessel, starting from 911, 950, 973. As you can see, Evadne, Pandalus, Bernicia. Now, when we come to 2011-12, we said that, okay, if we have a new research vessel, what will be the name? So that was something that we were thinking. So we said, I told my students that I always have group of students, maybe 5 or 6 of them. Let's establish a project. Let's establish a project to have a new research vessel. So what will be the aim of this project or the objectives? We said, first of all, it should be a modern vessel, innovative, flexible, and practical. And also it should have a very good, of course, stability, safe, and seakeeping should be very good. Efficiency, maneuverability, everything should be much better. And then we also have, even those days, small carbon footprint, i.e. the fuel consumption should be less. And also, most important thing, I told my student that you guys should involve, you guys should design. So I wasn't sort of going myself, and then we were going to design all students together. And also this vessel should belongs to the region, because we were in the northeast of England. Maybe some of you know, Newcastle University is in the northeast of England, next to so-called North Sea. So we should collaborate with the industry in that region. And so we thought that this should be very good for the Northeast. If it is Northeast, then we should make use of our assets. As you can see, this boat here, that's a very, very interesting traditional fishing boat. It's called Cobble boat. You can see Cobble boat has got a very interesting bow shape here. She has a very sort of deep kind of going vertically downwards, drooping. We call drooping bow. And also often has got some kind of a propeller pocket. You may wonder why this vessel has got a bow like this and then pocket like this. Bow, when you are pulling the fishing boat to the shore, to the sand, you want to have a strong bow. So therefore, this is really had a really good bow, a very strong bow. Why you had a kind of a hollow section at the aft end? It should cover the propeller. It should protect the propeller and also provide some draft. When I was looking at that, I also read 1 or 2 papers. They said that if you have a bow like that, when the ship is going in the waves, when it's doing slumming like that, having a droop bow always keep the bow in contact with the water. So people on board doesn't experience slamming. It's always in the water. If it was flat, then it comes out, bang, it hits on the water, then there is a lot of slamming. So this was good design. It wasn't really only for beaching the vessel, pulling to the sand, but it was good for seakeeping. I said, that's excellent. Let's actually mimic. Let's bring this design into our design. Of course, in Newcastle University, I was also interested in so-called deep V vessel designs. And then I thought that how we can bring this bow, how we can bring this stern to our design. So I brought together, as you can see, 1, 2, 3, 4, 5, 6, 7 undergraduate and postgraduate students. I told them your project this year, design a research vessel. In the meantime, with one of my PhD students, we actually already designed a catamaran research, not the research vessel, but catamaran hull form design. That means you can have 100 or 150 various hull forms, but they are all based on so-called this deep V form design. In fact, in 2012 Olympics, when the Olympics was held in London, the company called Port of London Authority, they asked one of the local company in Newcastle, can you actually design 4 ships for us? This company, which is called Al Maritech, I knew them. I told them that, look, why don't you promote, why don't you propose our deep V design? And London Authority, Port Authority accepted our deep V design. And then this company in Newcastle called Al Maritech built 4 of these so-called fast patrol vessels you can see over here. So therefore, before actually our student designed the research vessel, we already have 4 fast ships for the London Port Authority. So we have a really good reason to apply this deep V concept to research vessel. Then we establish a team. As you can see here, so many people, so many students, and so on. And I went to the university rector, our principal. I told them, can you please give us some money? He told me that, Mehmet, I can only give you £500,000. That means 600,000 pounds. That's all money I've got. I said, okay, if we can have this £500,000, maybe we can ask our rich alumni, our rich graduates, because there are so many rich graduates all around the world. Can you give us some money to build this vessel? So we started a campaign to raise further money because we needed 1 million, whereas we had only 600,000. So then in the meantime, with my students, we decided to specify the vessel mission. We said that, okay, this vessel should do all the old vessel Bernicia does, like the trawling, static gear, fishing, dredging, etc. But on top of that, because you guys are marine technology students, you need to know what the cavitation is, what the performance monitoring is, what the coating effect is, you know, what apart from the marine science, we also introduced this vessel so many different missions that can be useful for the marine technology student, because this vessel should be used marine technology and marine science students. So therefore, we should have a lot of different features. So apart from this mission, as you can see here, this vessel will be a deep V catamaran, V-shaped. You remember, like a cobble vessel with the droop bow, flexible vessel. We will have a large deck, and also in the deck we will have moon pool. That means there is a hole in the deck. You can put the things through the deck and you can retrieve. I will explain you. And this vessel can be doing some wind farm support, like you can go to a wind farm and then do some support, and then it can do good station keeping, and it should have a performance monitoring. And also we said this bow section should be novel. If we wanted to, we can change the bow section. You can see that there is a bulbous bow here. Maybe we can change the bulbous bow with a normal bow. So things like that. It's all innovative vessel. Anyway, then we specify all the equipment. We had the A-frame, and then we had the troll winches, hydrographic winch, and then the pot haulers, moon pool, wave radar, motion sensor, and all the other equipment, as you can see here. Then what about the vessel size? We said, I think this vessel should be around 20 meter, 19, 20 meter. Beam is 7 meter, draft 1.6 meter. Maximum speed, we said 20 knots. Cruising speed about 15 knots. That will require two 600 horsepower propellers. And then it was going to be a direct drive diesel engine, two propellers, of course, and hull will be made from aluminum because it is relatively fast ship. So the classification is the Lloyd Register MCA, Marine Coast Guard Agency category. Okay, so after that, we have come up a ship like that. It's very unusual. You can see that the bow has got the droop like a cobble boat. Often has got the propeller pocket like the cobble fishing vessel. You can see that. But one thing was very different. Cobble never had a bulbous bow, but we introduced bulbous bow because bulbous bow will save a lot from the power. Eventually, vessel has become like this. The hull is a deep V shape, and then the bow has got the bulb. Often has got so-called propeller pockets and two 5-bladed fixed pitch propeller. You can see the A-frame here. You can see a dry laboratory here, wet laboratory. Sorry, not the dry one. The dry one is inside. And one large navigation and then the laboratory. That was the expected outcome of the vessel. I mentioned to you that hull form is like a deep V. You can see that the deep V hull form. This is a normal catamaran standard round bilge or transom at often. You can see the difference. How deep V is different to the round bilge standard catamaran. This will give you very nice sea keeping motion. Vessel go into the water and come out very slowly compared to this flat often round bilge. They make a lot of slamming. This is not good. In fact, before I was dealing with this deep V shape, there were a lot of monohull high-speed ferries in Mediterranean. You can see that these ships are passenger ferries. They can go very fast. They can go 40 knots, 50 knots. But my aim was to apply this V hull form to catamaran. This is what we have done in Newcastle University with my PhD student. You can see that before we built our research vessel and this London, if you like, the Olympics vessels, we already developed catamaran standard series in Newcastle University. You can see how these deep V hull formed and how catamaran. We basically take this standard series and then apply to our research vessel. Okay, as I already mentioned to you that we already designed for the Port of London Authority. You can see these vessels. There are 4 of these vessels now in Port of Thames in London, and they are called Lambeth, Southwark, Cube, and Barn. These are all bridge names in the London Thames River. They now all operate in London. So apart from our research vessel, there are another 4 ships existed as the deep V catamaran in the open literature. So this was the bow section, as you can see, very similar to the cobble fishing boat, but we modified this bow section further. We introduced a bulbous bow, as you can see here. And then I told you that when we introduced the bulbous bow, we said we should be able to take this away and then replace with the previous bow like that. And then whenever we wanted to use normal bow, whenever we wanted to use the bulbous bow. This was a good idea. In fact, when we were manufacturing, we also make sure that this was demountable. But after a while, the company, the shipyard said that, Mehmet, this is very difficult. So therefore, although we built this aluminium, but I don't think we will be able to do this from the plastic, because we thought that bow can be composite or plastic. Anytime we can take this away and then put it back. So therefore, eventually, it was only one bow section, which was bulbous bow, as you can see here. Then often, as I told you, if you have a propeller pocket like that, this protects the propeller, first of all. This reduces your draft. Then you can take the propeller further up. And also the weight, the flow going to the propeller accelerated from this aft end, which is very good for your propeller. If you like the flow, propeller enjoys this type of. So therefore, we have introduced this in our research vessel, as you can see. Okay, you may ask to me, okay, Mehmet, if you go from normal bow to the bulbous bow, what do you say? Here is what you can say. This is the wave resistance, and this is the fruit number or speed. You can see that the normal bow is almost 20% more resistance than the bulbous bow. If you put a bulbous bow, you can reduce the resistance almost 20%. In the total resistance, this will reflect maybe 10% saving. So this is why we wanted to use the bulbous bow. Then we, of course, use computational fluid dynamics for all the other hydrodynamics part, but important things, we had to do a model testing. There are two model tests. One is large model, about 3.5 meters. Another one was small model, about 1.5 meters. The large model test was done in Istanbul Technical University. Istanbul Technical University is my alumni. I was graduated from Istanbul Technical University. I asked these guys, can you do this test for me without charging me? I can pay everything. Maybe we can do joint publication. We can collaborate, but I don't have money. They were very kind. So then they built model, and then they did the test. And then the small model that we have built was in the Newcastle University's small tank. We have a small tank, about 35 meters, 40 meters. As you can see here, we tested this vessel. Also, we built the superstructure. We tested this one in the wind tunnel to see what is the wind resistance of this research vessel. So, of course, that the propellers we designed ourselves, 5-bladed, and then propeller that can provide the vessel 20 knot speed in high speed, 15 knot speed in cruise, and also 3 knot speed in bollard pull, because you have to do bollard pull. Then Newcastle University has got a cavitation tunnel. We also did some cavitation tests, as you can see at the bottom. So all these tests has been done. Then the design has finished. The only thing we haven't done in our university was the structural design. That was done BNT, Nigel G. This was an outside company. You can see that ship was built from aluminium in a local yard called Alm Maritek. Alm Maritek is a local yard whose owner was my friend. We used to work together when I was working for industry, BNT. I told him that you have to manufacture a research ship for us, but you shouldn't have too much profit, because this is for the region. You have to contribute into that. So he was very kind. He built the vessel very cheap. So you can see some pictures when the vessel built upside down, and then after that it was turned, and then it's finished. Then after that, we put that onto a trolley. I will show you a video film. Then pull it and then lift it by crane and then put it into the water. So this took 1 year. We started in 2010. September, we finished 2011, August. So then after that, the boat was in the water. We had a ceremony. And as you can see, we decided to give her name, the Princess Royale. You can see that Her Majesty, Princess Anne. And this is me, and we invited her to open the ship, to launch the ship, and then after that, asked to give her name to the ship. So our vessel now called Princess Royale, and I am very proud of it. So she is actually now carries the name of the Princess Anne, as you may know. Okay, this was in September 2011. Now, there are very interesting things in the ship. As you can see, we have put some windows. Through these windows, you can observe the propeller, which is very good for you. You can see whether the propeller is cavitating or not, whether it is making a lot of noise or not. You can see how the propeller can be seen. You may ask me, why Mehmet coated the propeller? You can see blue color propeller. Because if you coat your propeller, it's good for you. It keeps the fouling away. No biofilm, no barnacles or mussels and etc. It's good for you. Because we were also doing research on coating. And also we have attached, as you can see here, electromagnetic speed measurement system. You can see that in here. And then the shaft has been strain gauge to measure the thrust from the propeller and then the torque. This is very important for marine technology student to measure the thrust and torque. Marine science student never interested in that, but marine technology student should be interested in that. So then total project of the entire design was 1.4 million, but the vessel itself is cost us almost £1 million. So this 650,000 pounds came from the university, but I was able to raise another 400,000 pounds from the alumni. You can see that Newcastle graduates, everybody helped us. And also we have got some money from European Commission. They were also very nice to us to present some, if you like, contribution. As you can see, these are all my students. And once we achieve all this, and you can also see that there is actually a station, marine station. European Commission also paid us some money, use this marine station as the home or port for the Princess Royale. As you can see here, there are maybe 50, 60 names. All these people gave us some funding, money, during the raising funding for the ship. So I'm going to continue on this one, but I've got a 5 minutes of video, whatever I told you to show. Let's watch this video, and then you can see maybe better what has been done. I will talk at the background wherever is necessary. Okay, here we go. Yes, this is actually how the ship looks now. You can see that. Can you see this part? That's for docking for the wind farm. When you go to the turbine wind farm to dock, because this vessel is a wind farm support vessel. Yes, this area here. Okay, this is the small model tank, model test in the Newcastle University. You can see this small model. We have made this one in our facilities in the Newcastle University. You can see the bulbous bow shape. You can see the aft end. Now, these are the small model tests in our small towing tank. That was kind of a resistance test. You can see that this was supposed to be almost design speed, 20 knots, the maximum speed of the vessel. These are all my students. They did this test, like you guys. Okay, after the small test in Newcastle University, we have done CFD analysis to design the bulbous bow, aft end, etc. Of course, this is very, very important. And then later on, in Istanbul Technical University, big model was manufactured and built, as you can see here. This is a big model, almost 4 meter, 3.5 meter. And you can see that the skeg and then the bow shape. And eventually she goes into the water in towing tank. I believe in Indonesia, in ITS, you also have a very nice facility, large towing tank facility that you guys can also use this type of facility. In Strathclyde University here, we also have a very nice facility. If you ever come to our towing tank here, you can also see these facilities. So she's in the water now. Then, of course, we have done resistance tests, and we have done self-propulsion tests. We have done so-called paint test. This is with the first bulbous shape. When we design the bulbous bow first time, we run into some trouble. It starts to make a spray. Then after that, we revise the bulb. We change the bulb shape. And then that was much better. Of course, that some of these things you cannot see in computations, but you can see in the model test. So you can see very nicely acting in the towing tank. So after the resistance test, we conducted the self-propulsion test. And then to see the flow around the ship, you have to do paint test. You apply some paint, and after that you tow it. You can see, depending on the direction of the paint line, you decide this is a good shape or bad shape. So after the model test, of course, everything is finished. And then in very near Newcastle, the manufacturing started in Almaritech from aluminium. You can see that the first day in manufacturing the ship, you can see that's me over here talking to the designers and manufacturers. So the vessel now is being built, as you can see, upside down. I put a spy camera and then take every day, add that together, then you can see how the progress has been done over 1 year. As you can see, some movies is night, some movies is on the day, and some is in the summertime, some is in the winter time. And but nicely, both hull is being manufactured. You can see how actually progress the construction. Yes, it's getting colder. As you can see, they are covering it. And all these activities, manufacturing activities, finished in 6 months. Then after that, we took the ship outside. We turned upside down in the crane. You will see just in a moment. Okay, turning the hull now. It was a very, very cold day. A lot of snow on the floor. You will see. It was very dangerous to turn it, you know, because this is a small shipyard. This was already 30 tons. You can see the snow. And the ship is being turned over. Okay. Here you can see the moon pool. Maybe just a moment. Yes, this is the moon pool. You can see this opening here. That's the moon pool. You can put things into the water and take it outside the water. This is very, very handy for research vessel to have an opening like that. Okay, then you can see how actually the actual hull form of the ship. And that in August the 16th, we put this one onto a trolley and then bring to the river. Then after that, lift it by the crane. This is almost 43 tons now. And then put it into the water. Yep, she's going into the water now. Okay. So when she's in the water, she met the design draft and everything. Everything was okay. Then, of course, we have done the sea trial. You can see the propeller, how from inside, from the engine room. And then the trials indicated almost 21 knot speed, which was, we meet our ambition, like 21 knot maximum was very, very good. And then the vessel was doing what speed was requested from her, as you can see here. I know that my time is coming to the end. Give me a couple of minutes, it's finishing. You can see now, this is our first day in the water and doing some trials in here. Although not much, I can show. This is North Sea, and then this is the navigation desk, and this is aft end of the vessel. You can see very powerful, 2 times the 600 tons, and this is the Captain Neil, and you can see that all the monitors are very new with their nylon cover. This is the bulbous bow. When the vessel is in action, you can see. So I think mission was accomplished and we were very happy. And the vessel now, she is how many years old? 10 years old now, and working very successfully and bringing us a lot of projects. And in Newcastle University, of course, I have left Newcastle University year 2017. Now I came to Strathclyde University, but I keep in touch with them. The vessel still action. As you can see, this is how she looks. And so that was very, very interesting and having this concept. So this is actually a painting of the ship, and it was a present to me from a local painter. These are the bridges of Tyne Bridge, famous Tyne Bridge behind the vessel and Newcastle. Of course, university gave us only half of the money. The other half came from Newcastle Marine alumni, all the graduates. But the most important thing, this project actually was the achievement of my students like you. You can also design, and you can also manufacture research vessel for your institution, PTNS. You can do that with your students, with your lecturers. In fact, when I came to Strathclyde University last year, I gathered together 5 students. There you go. This is Pascal, Luis, Luisa, Roberto, Sergio. I asked them, you have to now design a modern research vessel. They designed a new research vessel driven by hydrogen. In fact, there were 2 groups. One designed trimaran, another designed catamaran. I am just showing you the catamaran. The company is called SAMS, that is Scottish Association for Marine Science and Association. These are institutions. That's a very big institute for Scotland. I asked them, would you like to change your vessel? They have an old vessel, Calanius. They said that we would love to. I said, okay, then let's come together. Strathclyde University, Glasgow University, and then the SAMS. We will design your vessel. My student will design your vessel. Then we can all use it. They said, let's go for it. Eventually, last year, these students designed, actually, 6 students designed this research vessel driven by hydrogen, and then they call it PLARS. What does PLARS mean? First name of Pascal, first name of Luis, first name of Arturo, first name of Robert, first name of Sergio, PLARS. This is like a joke. But now we will be presenting this research vessel to the SAMS executive board. Hopefully, we might have another research vessel, but this is very, very innovative now. And also, there are a lot of good features and for the next year. Let's see. But I will encourage you, you can replicate, you can imitate the same things. So with this, I will finish my presentation and thank you for listening to me. And then I hope that this presentation has inspired you then what you can do in the future with your school, with your university, with your institution, and with your country. This is not very difficult. You can do it. Thank you very much. I think I will stop my presentation. Back to you, Mr. Moderator. Thank you.
Thank you very much for the presentation, Professor Mehmet Adlar. Now let's
Thank you.
continue to the question and answer session. If
Sure.
you have any question, please raise your hand or you can write the question in the chat session.
Please don't feel shy. Ask the question. Anything that you like. You have been very quiet and
No, Prof. Mehmet,
sure.
Prof, I'd like to know how you inspire the alumni of Newcastle to support your project.
Yes.
It's really
Thank
very difficult.
Thank you, Echo.
Yeah.
I was a little bit lucky. Echo, I was a little bit lucky. You know why?
Yeah.
Because in 2003, university decided to amalgamate research, marine science and technology. So when you come with the new school, and
Okay,
also
Mr.
Sure. Just a moment, let me finish this one. And then when I come, I always visited the research vessel. I always talk to captain. I always talk to my colleagues, the marine science colleagues. I said to them, this research vessel is not good for you. Let's do publicity. I talked a lot with the vice chancellor. I talked a lot. I told them that I can apply for funding. I can raise the funding. So I really, by that time also, you know that VAT, this is actually a tax. By that time, government decided that universities can use the VATs for other purposes. And suddenly they had the money in their hand, almost $500,000. They said that we can give this money to you. So after this, then I can top it up. If I have the half of the money, rest I can do it. Now in Strathclyde University, I am also doing the same thing, but in Strathclyde University, we have SAMS, that's the Scottish Association of Marine. They already want a vessel. They want to have a new vessel. I am trying to convince them that maybe we can do, and coming together, I can get half of the money. My university can also pay. I can also get money from alumni. You know, people willing to give money to you, graduate. That's it.
Okay, Prof. We hope that I heard that you will visit Indonesia.
I like to do so. Yes, I hope
Yes.
so. Yes.
And then
Yes.
please help us to convey our alumni, our
I will do that.
association, yeah, to do the same
Yes,
thing
I will. Yes.
what you have
Yes,
done.
I will do that. Yes,
Okay,
I
thank
will
you,
do
Prof.
that.
Thank you, Prof. Yes.
I think one wanted to ask me a question from outside. I noticed this one. Suddenly, I stopped him. Please ask me your
Yep.
question.
Any other question?
Sure.
Please raise your hand or you can write in the chat.
Maybe it was accidental, Priyambodo.
Okay, we have one question from
Sure.
Ojik, please.
Sure, Ojik.
Okay. Good afternoon for Mr. Mehmet. I want to ask you something about that ship. Like, where is the place of freshwater tanks and ballast water tanks on catamaran? We know that it have a unique shape, like multi-hull type. Is there any special calculation for the placement of the tank? Thank you, sir.
Thank you, Ojik. It's a very good question. And then we have actually place the tanks, some in the so-called in the deep V hull, right at the bottom, and some at the so-called the wet deck area. Wherever we wanted to have access, put it in the wet deck area. Wherever we don't want to have access, like the fuel tanks, in the deep V tank. The calculation nowadays you can do with many design software. That's very, very easy. Okay.
So there is any special calculation about how to place in that ship, sir?
To be honest, there is no special calculations. You know, I think as soon as you decide where you want to put your tank, that's the most important thing. Of course, you need to watch the trim of the vessel. You know, when you start to put far away from the center of buoyancy and etc., then you have to be careful center of gravity. As long as the stability is okay, you can locate by using the software. I mean, nowadays, like many software, Tribon or, you know, all kinds of other software provided by different companies, and you can do it. That's not a big problem. Okay, any more question, guys?
Okay, thank you very much,
Thank
Oji,
you.
for asking the question.
Sure.
Any other question from the participant? Professor, can I ask you one question?
Please.
Yeah. Okay. Thank you very much for delivering the presentation today. Actually, I don't have any marine engineering background, but the way you deliver the lecture was quite clear about the design and operation experience with the university research. Can you tell us more about the way for the designing the vessel? Did you do some calculation using software and compare it with the experiment, or do you have any other experience about that in
Yes.
the designing process?
Yes, Priyambodo, yes. Everything is relies on the software and then the models test, as I mentioned in the presentation. But the key thing was the selecting the hull form. You know that the hull form, DP hull form. Before we started this design, one of my PhD students did a PhD, 3 years. They developed hull series. That means anybody can go into this design database and then they can select the hull, and then that hull for the start, for the basis is okay, but you still have to modify for your size, for your requirement. And in our case, it was a 20-meter long, 7-meter beam catamaran for research vessel. But in other application for the London Olympics, it was 14-meter fast patrol boat. So you can use this design data as a basis, but you still have to do a modification to this design database by using computer software, like the design software and also computation fluid dynamics software, and then calculating seakeeping, maneuvering, and then the resistance, powering, that all done with computational software, to be honest. Nowadays, more and more CFD. In those days, in 2010, we can still use some lower fidelity design software, but nowadays, all high fidelity computation fluid dynamics spec design software. Yes, then we also did a lot of so-called model tests, as you can see, 2 sets of model tests, one with small and one with large model. And also I have done cavitation tunnel tests and in Newcastle University. As an answer to your question, we use all these methods and the computation software as well as the model test. Yeah.
Thank you very much, Professor
You're welcome
for delivering guest lecture today.
You're welcome.
Okay.
You're welcome. Okay, thank you all, guys. I wish you all the best in your lectures, in your new academic year, and I hope to see you in one time. If
close
you need
this
any
session.
question or something, please ask me. Okay. See you later.
Before we close this session, let's give a big applause to Professor Mehmet Adlar.
Okay. Thank you. Thank you very much. Thank you. Thank you. Okay.
Okay, we will start the second keynote speaker. Let me introduce Ibu Tu Artawibawa, PhD M. Raina. She is currently working as an academic staff in PPNS. The subject of his lecture are drawing assignment, lines plan, general arrangement, hull structure drawing, basic ship design, and non-ferro boat building. He is also currently the head of collaboration and public relation unit in PPNS. Ibu Tu Artawibawa graduated from ITS, the Institute Teknologi 10 November, Surabaya, Indonesia, acquiring his Bachelor Engineering and Master of Science, majoring marine production and small craft design. After that, he obtained his PhD degree from Newcastle University, United Kingdom. The thesis studied was sustainable fishing vessel development by prioritizing stakeholders' engagement for Indonesian fisheries. Today, he will present his research entitled High-Density Polyethylene for Sustainable Fishing Boats in Indonesia. Mr. Putu Arte, the time is yours.
Thank you so much, Pak Dido, Pak Priambodo. Good afternoon, everyone, and also good morning for our colleagues from University of Strathclyde. It is a great honor for me to join this conference as the project manager for the UK Skill for Prosperity project. I'm very happy and very proud of all of you students because finally you can running this program, and I hope that all of you today will can share your thought, your finding, and everything in terms of research. My presentation will be quite short. Let me share my screen. Okay. So this presentation will related to what we have been doing in the last few months in PPNS as a part of our research to develop the fishing vessel in Indonesia. So the title of my presentation is High Density Polyethylene for Sustainable Fishing Boat in Indonesia. Why I say the sustainable fishing boat, because Indonesia is one of the biggest country, the second after China in terms of capture fisheries. So we have a huge number of fishing vessels in Indonesia, and there are still quite a lot of problems that we found in the traditional fishing boat. So that's why, as a institution in vocational education, we need to take a role in any development to ensure that this sector will be sustained in the future. If we talk about the fishing boat in Indonesia, existing fishing boats are generally made of wood. So most of fishing vessels in Indonesia made of wood, but in the last 10-20 years, I think it is more difficult to find a good quality of wood with a certain length of wood. So right now, start from I think 2002, 2003, after the tsunami in Aceh, quite a lot of fishermen then moved to fiberglass reinforced plastic for their fishing boat. But the problem with the FRP is there's global issues related to the environmental impact of this material, because not only this material is a toxic material, the other issues is in terms of the recycle or the reuse of the material. So both materials, wood and fiberglass, there's still a huge issues for environmental friendly material. So more environmental friendly material is needed to substitute wood and FRP in the futures. The other problem with the traditional fishing boat in Indonesia is most of this fishing vessel is a small fishing vessel up to I think 3 gross tonnage. So quite a lot of them have a very limited technology on board, and you can find a very huge number of fishing boats that have the outriggers. So especially for the long boat, because they need to ensure the stability of the vessel, so they put the outriggers on both sides of the boat. The problem with the outriggers is some reference said that there will be a problem with the maneuverability of the vessel, and also increase the ship resistance. And also, if you can see in the pictures, there's a problem with the space efficiency if the boat do pitch landing or at the home port. With these two problems, we try to overcome the problem with propose a new design for the fishing boat, and also propose the new materials. I mean, try to implement the new material for fishing boat in Indonesia. So what we try to introduce with the fishing vessel in Indonesia is implementation of high density polyethylene or HDPE. Right now, actually, there's already some boats in Indonesia that have been built with the HDPE, but the number is very small, and not many fishing boats made of HDPE right now. So PPNS in this case try to introduce this kind of material as well to the shipyard, to the boat yard, and also to the fisherman community. This project we have a collaboration with 2 boat yard in Surabaya. Both of these boat yard actually, I mean, their core business or they're familiar to build a boat with the FRP and aluminum. They don't have any competencies in build the boat with the HDPE. So our collaboration with those 2 fishing boat yard is try to design and then try to build the boat. So both human resources in PPNS and at these 2 boat yards, they will have competencies in build this kind of boat. So why HDPE? Why high density polyethylene? There's many advantages actually. We talk about the high density polyethylene for boat. First is because it has very impact resistant in case of grounding, and then it's also thermoplastic materials that can be recycling or can be recycled. So this is good for environment. I mean, if you talk about the more environmentally friendly materials, I think HDPE is one of the alternative that can use in the futures. HDPE also have no problem with defect in terms of like FRP. We have delamination or osmosis. We don't find any problem with that. And then in terms of life span, it has life is up to 50 years because it has no very low corrosion rate. And also for fishermen, it is important for fishermen is SDPE hull does not need any anti-fouling paint. So for fishermen, it will be good because be lower their operation costs. Because right now, if they use let's say a wooden boat for their fishing vessel, they need to do the recoating and then repainting for the anti-foulings almost once in 3 or 4 months. So it's quite high maintenance cost for the fishermen. Also, SDPE is very light, so it's good, especially for fishing vessel or fishing boat, because it will be increase the capacity of the boat itself. To implement the SDPE for fishing boat in Indonesia, we also do some research in terms of the mechanical properties of the SDPE. Why we do this kind of research? Because the problem with the SDPE for material for fishing boat in Indonesia is right now the existing condition in Indonesia, there is no fabric manufacturers that produce SDPE sheet or SDPE plate. So we still import from other countries, especially China. So both material SDPE sheet one, the plate one that we can use to build the boat right now is import from China. So yes, there's next challenges actually for Indonesia if we want to use this kind of material for fishing. But still, we need to do the research. We need to try how to build this boat with this kind of materials. We hope that in the future there is more manufacturers that produce this kind of materials as well in Indonesia. So in terms of flexure strength and tensile strength, we compare this both materials. I mean, Agru and Roping is from China. So the difference between this material is in the price. Yeah. So the Roping is more expensive than Agru, and I think it'll be quite difficult actually to introduce this kind of materials in Indonesia. But still, we need to do the research for the future's development. The other issues that we try to overcome is about the outriggers. So you can see this kind of traditional fishing boat in Indonesia. Quite a lot of them already changed from wood to FRP, but the design is quite similar and still the same with the previous one, with the wooden boat. And also the outrigger system, they still use it, especially to put the engine on the outriggers. The problem with the outriggers, according to difference, is they have higher engine power required, about almost 50% higher if they use the outriggers. Also, they reduce the maneuverability of the boat, and also a greater space requirement when do docking. What we try to do is try to implement or adopt the concept of RBB, rigid buoyant boat for a fishing vessel. So the concept of RBB is there's a tube on both sides of the vessel along the gunwale of the vessel to increase the stability of the vessel. So right now in Indonesia, you can find quite a lot of the LBB, but only for the petrol boat, and also for a pleasure boat. And now we try to use it as the concept to adopt it for the fishing boat. So yeah, this is the concept that we try to implement. The fishing boat without pictures, we would like to redesign or do the new design to implement the rigid buoyant boat concept to fishing boat. So this is the design that we finished for the fishing boat with the LBB. With the LBB concept, the length of the vessel is 7 meters length with 1.5 meters beam, and also the draft is around 0.4 meters depth draft. This is the general arrangement of the vessel. So because most of fishing vessels in Indonesia, they have no accommodation space, and now in this design we try to also put the proper accommodation. Well, not really proper accommodation, because most of fishermen will be go only for less than 24 hours or 1 day fishing. So I mean, the accommodation is not too complicated for this design. So we already start the fabrication stage about I think 1 to 1.5 months ago. So we use CNC rotor, sorry, to fabricate the internal construction, the frame, the floor, and every part of the boat. So it make it more simple for us instead of using the manual tools. So this part is part of PPNS facility, so it's really support the project as well. The next stage in fabrication is for the tube. We use fusion method. So it's not by welding method. It's just using the fusion method to do the jointer of the tube. And then this is the result of the floor here, using the CNC cutting rotor. This is the tool that we have in PPNS. So we have tool to do the extrusion welding and hot gas welding as well. So the next stage is the sub-assembly or assembly stage. So all the process we have done in PPNS in our workshop. As you can see, our students also involved in this project. Then, yeah, there is also a technical assistant that we hire to teach our students in our lectures how to do the welding process. So this is the welding process using the extrusion welding machine. Then this is the result of the assembly process. And then, yeah, this is the next stage. We turn over the boat and then do the inside structures, inside construction. And then this is the next process. So we put the bulkhead, the bulwark around the boat. So it is, yeah, quite nice. I mean, in my opinion, we completed in almost 1 month the process. And then this is from inside. Well, there's still another progress. I mean, we still need to install the the accommodation space, yeah, for the fishermen, and also complete the others structures of this construction. Yeah, about 2 days ago, 3 days ago, we put it in our trial pool, just in our backyard in the PNS. There's still yeah, some adjustment we need to do before we put it in the real condition. So we want to try it, sea trial involve the fishermen as well. So the fishermen will try this kind of vessel. So actually with this I mean, this program, we try to involve the fishermen as well. So they have the overview. They have the you know, the experience with this kind of materials and this kind of design. I think that's all that I can. A very short presentation about what we have done in PNS so far in terms of how to you know, introduce a new material. In this case, the high density polyethylene to the boat yard and also to the fishermen. Thank you. Back to you, Pak Dido.
Thank you, Pak Arthur, for the
Thank you, Pak.
presentation. Now let's continue to the question and answer session. If you have any question, please raise your hand, or you can write the question in the chat section. Don't forget to turn on your camera and use the virtual background that already shared by the committee before this. Okay, Pak Atta, can I start the question?
Yes, please.
Have you done some research about the comparison by using this new material? I mean, if we want to encourage the fishermen to use the new material, there must be some advantage to them. Maybe it's more cheaper, or it's easier to use, or etc. Do you have any ideas about that?
Yes, Pak Dido. Well, we haven't started with that kind of research, Pak Dido. I mean, right now we just found that the price of the material is quite high. It's similar with aluminium, but of course, because if we talk about the wood, timber, teak, for example, will be more expensive in the future. It will be quite difficult to find. If there is some manufacturers in the futures that can produce it in Indonesia, I think we can reduce the price, the cost for the boat, and it'll be good for fishermen to use it in the future, because there's many advantages, including low cost of maintenance. So it'll be better if they can use this kind of materials as well. Yeah.
Thank you very much, Pak Arthur. We have a question from Bagas. Bagas, please.
Okay, excuse me, Mr. Arta.
Yeah.
My name Bagas Rahmat from PPNS. I have some question. Can you sharing about obstacle during this project make HDPE about? Thank you, sir.
Yeah. Well, thank you, Bagas, for the good question. Well, because this is the first time that we built this kind of vessel. Yeah, we have quite long experience with FRP, fiberglass, and also wood. But this is our first time to build this kind of boat. We don't have any, you know, good reference about. I mean, there's no many reference according to how we use this kind of material for boat. For instance, right now there's only I think two from Turkey and from DNV regulation that can support us when we try to calculate the scattering, for instance. Indonesia, we don't have that kind of regulation right now. So BKI, our classification bureau, think they will start, discuss about that kind of materials few years later. So the problem is we don't have any reference for that, and also especially how to using the welding machine, Mas Bagas, because we still need more practice and then more experience in using this kind of machine, welding machine. Yeah. Thank you. That's all, Mas Bagas.
Thank you very much, Pak Arta and Bagas, for asking the question. I encourage all of the participants to ask some question to Pak Arta. There will be some interesting giveaway from the committee to those of you that the most active participant in this conference. Is there any question to Pak Arta? Okay, Pak Arta, I think we can.
Well, if there is no question, Pak Dido, please, for all of you as students of PPNS, I mean this booth is in our workshop. So if you are interested to study or learn more about the SPPE, please come to non-metal workshop so we can discuss further about this kind of materials. So we can develop this kind of material together in the future. Yeah. Thank you, Pak.
Thank you very much, Pak Arta, for sharing this presentation. I will return the session to the committee. Thank you.
Thank you, Dr. Priambodo Nur Ardi Nugroho, for taking the lead of our astonishing speakers, and as I could give a compliment for an excellent presentation and lecture from our keynote speakers. I hope the participants here could increase the knowledge and apply to research and innovation related to maritime sector. Okay, distinguished delegates, ladies and gentlemen, now we've come to our main agenda. There is the presentation session that also led by moderator. Please welcome our moderator, Aida Nelawati Rosa, a student from Safety Engineering Study Program in PPNS.
Thank you, Aura. Good afternoon, ladies and gentlemen. Now you're with me, Aida Nelawati Rosa, as the second moderator of International Student Conference 2022, hosted by Shipbuilding Institute of Polytechnic Surabaya from Indonesia, in collaboration with University of Strathclyde Glasgow from UK. In this session, there will be presentations from our several presenters, which are 10 students from Shipbuilding Institute of Polytechnic Surabaya and 5 students from University of Strathclyde. They'll be presenting their excellent paper with the theme of enhancing the sustainable use of ocean-based resource through innovation on maritime technology. In this presentation session, each presenters will be presenting their paper for 10 minutes and continue with question and answer session for 5 minutes. And before we start, I encourage all of the participants to feel free to ask, because there will be special reward for the most active participant. Okay, without any further ado, let's start with our first presenter. It is from Ahil Muralidhar, student from University of Strathclyde, with his paper titled A Study on the Penalties of Heterogeneous Hull Faulting. For Ahil Muralidhar, the time is yours.
Hello, am I audible?
Yes, you are.
Okay, so my name is Akhil. I study here at Strathclyde. I am doing my MSc in Advanced Naval Architecture. So I joined in September, and this presentation is based on the MSc thesis which I'm working on. The thesis is not yet complete, but it's an ongoing work. So I would like to share my screen. So is my screen visible?
Yes, it is visible.
Okay. So this is my topic. It's like a study on the penalties of heterogeneous biofouling. And so these are the contents that that will be there in the presentation. Initially, there will be a small section on the boundary layer theories, the concept of biofouling, and the results obtained with flat plates and KCS model. And I have developed some mathematical equations for predicting the fouling increase in effective power due to heterogeneous fouling. There will be some discussion on that, and towards the end, I will show the penalties associated with biofouling, heterogeneous biofouling. So this is the procedure or the methodology which I have used in my thesis. So initially, the results of flat plate experiment, flat plates that are coated with sand, that is used to predict a suitable roughness function model. And using this roughness function model, I have predicted the total resistance of the KCS model, which is a commonly used model by researchers for study for hydrodynamic study. And once the predicted results and the experimental results are compared, if the results are matching, we can say that we can validate the applicability of roughness function models. And using that, I have developed something known as added resistance graphs for the full-scale KCS ship. And using these graphs, I have predicted the penalties associated with heterogeneous biofouling. So initially, just to give a brief idea about what is biofouling, biofouling can be regarded as the attachment, growth, and colonization of marine organisms. And the main reason why biofouling is under a lot of research is because of the following issues related to it. One is there is additional fuel consumption because of extra drag, the monetary losses associated with the vessel not being able to maintain its service speed, the issue of global warming, the issue of corrosion to the hull, the release of toxins that are used on the paints used for preventing biofouling. So these are the different types of biofouling we can see. Broadly, they can be classified into microfouling and macrofouling. And I have included extra slides, so I'll be skipping through a few slides because I'm using this presentation for some other purposes as well. So these are the different types of paints which are presently in use: the CDP paints, SPC paints, and the foul release paints. The CDP and SPC paints, they release biocides into the marine environment, while the foul release paints, they do not release anything. They work on a totally different principle. So just to give a brief introduction on what is boundary layer, this shows the boundary layer on a flat plate. There will be a laminar section at the leading edge of the plate, then there will be a transition section and a turbulent boundary layer. So we are more interested in the turbulent boundary layer section. It can be divided into an outer layer and an inner layer. The inner layer has 3 sublayers, which are known as the laminar sublayer, as we can see in this diagram, the laminar sublayer, the buffer sublayer, and the log-low region. So I'm not going into the mathematical details, but generally what I can say is that each sublayer has a different velocity profile. And with increase in roughness, the velocity profile reduces, and how much it reduces is decided by a factor known as the roughness function. So I have included some mathematical equations here, but because of time limitations, I'm not going through that. So experiments were conducted on the flat plate and on the KCS model. So this is the dimension of the KCS model. It's a 1:75 scale ship, and the flat plate dimensions are given here. It's a 1.5 meter long plate. And these are the results which I have got for experiments with the flat plate. As we can see from this graph shows the total wave resistance, the total resistance, the frictional resistance, and the wave resistance. We can see that the frictional resistance is reducing with increase in Reynolds number. Similarly, we can see fluctuations in the wave resistance. This is due to the interference between the bow waves and the stern waves of the flat plate. So these results show this graph shows the results for the rough plate. We can see that the frictional resistance and the total resistance for the rough plate is much more higher than the smooth plate. And I have used something known as Granville's overall method to predict the delta U plus, that is the roughness functions of these flat plates. And then by using a suitable K value, that is a roughness height value, I have found that for a K value of 1.73 RT50, the roughness function values are matching with the predefined roughness function model for which is proposed by Nakuratse. So that is what is shown in these two graphs. And here there is something we can use. For example, if I have this coefficient of frictional resistance values for a flat plate, I can use it which is obtained by experiment. I can use it to get the CFR values of any ship length or any plate length. So we can use a method known as Granville similarity scaling method. So these are the results of the method. I'm not going into the details. It's slightly complicated, but anyway, I have used MATLAB for this purpose. So the second graph shows the results, extrapolated results for a 3 meter long plate based on the results which I got for the 1.5 meter plate. And Nakuratse model can be mathematically expressed by this equation. I have done some mathematical modifications to this expression and have expressed delta U plus and K plus purely in terms of the CFR, that is a coefficient of frictional resistance. And in MATLAB, it is solved iteratively using a inbuilt function, the VPA solve. So these are some of the results which I got. These are the predicted CFR values. CFR is the coefficient of frictional resistance, the predicted CFR values for the KCS model. And here in figure 5.10, you can see the variation in frictional resistance based on different roughness heights. We can see that as the roughness is increasing, the frictional resistance is increasing. This shows the dependence of length on the frictional resistance. And figure 5.12 shows the combined results of figure 5.11 and 5.10. So this shows the results for the smooth model. We can see that after Reynolds number of 3.8 into 10⁶, there is an increase in the CW values. Because this is because at higher speeds, the contribution of wave resistance will be much higher than the frictional resistance to the total drag. This results for the rough model. As expected, the frictional resistance and the total resistance for the rough model is higher than that of the smooth model. And this is an important graph because here I have used the predicted results, that is the results obtained using roughness function models to predict the CTR values of the KCS model. And that is represented by the red graph, red line, and the magenta line represents the result obtained by the experimental result. So there is good agreement between these two. So now this has validated the applicability of roughness function models and predicted the frictional resistance of ships. So the next step involves finding the result, the effective power for the full scale KCS. So I have used the ITTC 1978 equation for that. This is the ITTC 1978 equation. CTS equal to 1 plus KCF plus delta CF, CR, CA, and CAAS. I'm not going into the details, but this is the general equation that is used. And here, this graph shows the variation of these components with increase in velocity. And this graph shows the change in power and frictional resistance based on velocity. So now, after this, what I have done is I have developed something known as added resistance frictional graphs. These graphs are very useful because from these graphs, we can directly read the frictional resistance of the KCS hull for a particular fouling condition. So the concept which I have used is that Schulz is a famous researcher who has done a lot of work in this field. So he has actually done some studies on flat plates coated with different fouling conditions. And he has assigned roughness height values for different fouling conditions. So using that roughness height and a mathematical model that defines his results, I have developed these added resistance graphs. So if you see this, this is the graph for the anti-fouling coating. And from here, we can directly read, for example, if I take 10 knots, we can directly, for 10 knots, directly read what is the delta CF value and put this value or substitute this value in the ITTC equation and get the effective power. And this is the added resistance graph for medium calcareous fouling, heavy calcareous fouling. And on the right side, you can see the percentage increase in effective power due to different surface conditions on the KCS. So these are added resistance graphs that are developed for different ship lengths. So the advantage of this particular graph is that I can, by interpolation, I can get the delta CF value for any ship between the 100 meter to 350 meter range. So these are the added resistance graphs for different surfaces, for heavy slime fouling, for calcareous fouling, for medium calcareous fouling, and heavy calcareous fouling. And then what I have done is that based on the results of this added resistance graph, I have developed a mathematical equation from which we can directly calculate the increase in power because of heterogeneous fouling on the KCS. So equation number 11 is the equation for that. Though it looks slightly long, it is a reasonably simple equation where we just need to substitute the value of V, which is the velocity of the ship in knots, and the value of the coefficient C1 to C6, which actually gives the coverage areas for different types of fouling. So now I'm skipping to the next slide, the last section, which is actually the penalties. So based on the mathematical equation, I have calculated the penalties on the KCS. The KCS is actually a hypothetical ship. It doesn't have an engine. To estimate the fuel penalty, we need to fit an engine. So what I have done is, if you see this, I have selected one particular vessel that is presently in service. In fact, I have worked on this ship a couple of years before. So it's a container ship that is around 238 meters long. So it's using the MAN B&W engine. So I have access to the shop trial and the sea trial data of this particular ship. And using that, I have developed some, I have estimated the penalties associated with heterogeneous fouling on the KCS. Let's skip through the slides. And so this is the final result which I have got. So this table shows the fuel penalty and the environment penalty associated with the KCS. For example, if it's operating at a speed of 80 knots for different fouling conditions, we can see the daily fuel consumption, which is given by column number 3, and additional fuel consumption given by column number 4. And though the daily additional fuel consumption values are not that high, for example, for light sliming, it is 6.68 tons. For heavy calcareous fouling, it is 58.88 tons. Though it may not sound that high, but if you look at the cost figures, these are very high values. 1 ton of HFO, that is a very low sulfur fuel that is presently in use, costs around $872 US. So you can imagine if we are having an additional daily consumption of 60 tons, there will be a daily fuel cost penalty of $50,000 US. So, but this table is for a homogeneous fouling condition. Homogeneous means that the hull is completely and uniformly coated with one particular type of biofouling. But in real world condition, that's not going to happen. There will be a mix of different biofouling conditions. So I have done the calculation for that also. This is one particular condition that I have assumed, that there will be 28% of AF coating, 65% of lime slime coating, and 3% of small calcareous fouling. And these are the results which I achieved. This is much more realistic than the previous table. We can see that at the speed of 17 knots, there will be around $5,000 US penalty, daily penalty. And at the speed of 22 knots, there will be almost $15,000 US penalty per day. So these are the results which I am planning to include in my MSc thesis, and something which I would like to share with you guys. That is the end of my presentation. And finally, I would like to point out one future work I would like to do. I would like to do a CFD study and validate the method which I have proposed. So these are some of the references which I have used for the study. Basically some research work done by various researchers and papers published by ITTC. So that's all from my side. This is what I have to have for at this time. Let me just mention.
Okay. What an excellent presentation from Ahil Muralidhar. Thank you so much. And now we will open the question and answer session. If you have any question, please raise your hand and I'll allow you to unmute your microphone. But due to our limited time, so we're so sorry, but we just open only one question. Any questions are welcome. Okay, for Novario Cahya, you can unmute your microphone and ask your question.
Thanks for the time. Introduce myself. My name is Novario Cahya. I'm from PPNS. I want to ask you the simple question: what's the challenge of the pieces, and how did you overcome them?
Actually, I cannot clearly hear you right now. Your
Okay,
voice is breaking.
I replace my question. What's the challenge of the research and how did you overcome them? That's it. Thanks.
So if I heard rightly, you're talking about the challenge of the research?
Yes.
Yeah, the challenge was initially one challenge I faced that some of the experiments which are done with the flat plate and the KCS model, it's actually not done by me because we were having some maintenance issues at the KHL laboratory here at Strathclyde. So I have taken some readings from some research paper that was published by a researcher called Soong Seom. He was somebody who worked here at Strathclyde. And another research is to develop these graphs, I need to learn MATLAB because I was not using MATLAB before. So I had to learn MATLAB and I had to do coding because some of these graphs and some of these calculations require some high level of coding. So I learned MATLAB for 2-3 months. So that took a lot of time. And these are two challenges which I faced during the course of this paper. Is that okay? Did I answer your question?
Okay, I think enough. Thanks, sir.
Okay, thank you, Nafaria, for the question, and thank you so much for Ahil Muralizar for your presentation and for your answer. And we're so sorry, but due to limited time, we only limited the question with only one question. And again, thank you so much for Ahil Muralizar for your great presentation, and thank you for the participant for the question. And next, we're moving to another speaker. It is from Fortuna Fiaza Habib Ainuddin, student from Shipbuilding Institute of Polytechnic Surabaya, with his paper titled Motor Response Speed Control with PID and LQR. For Fortuna Fiaza Habib Ainuddin, your time is 10 minutes for your presentation, and the time is yours.
Okay, thank you for giving me the opportunity. This is the first time conference and I am so nervous. I think it's not quite what you were expecting, but I hope I can do my best to present my presentation. Here, I will present my presentation entitled Motor Response Speed Control with PID and LQR. But before that, I will introduce myself first. Next slide, please. Okay, hello, I am Fortuna Fiaza Habib Ainuddin. I am studying in Shipbuilding Institute of Polytechnic Surabaya. I'm from Marine Electrical Study Program, and you can find me on my Instagram at @fiaza_. Next slide, please. After introduce myself, let me start my presentation. For the first, I will talk about background of the study. Control system can have a positive impact on the output of a system. It can be shown from a better system response and less steady state error compared to a system without a controller. In this paper, optimal control of DC motor is designed using proportional integral derivative or PID method and linear quadratic regulator or LQR algorithm, where for controlling the speed of a DC motor, optimization is carried out by adjusting the values of the Q and R matrices, which can later change the value of K. The DC motor to be controlled must first be modeled in the PID controller so that it can be entered into the calculation of the LQR method. Okay, next slide, please. Next, I have three purposes of this paper, including for the first, able to control speed of the DC motor response as desired. Number two, able to understand the PID control method. And number three, able to understand the LQR control method. Next slide. The next is the literature review. I have three main reviews here. The first, of course, the PID controller. PID or proportional integral derivative control is a feedback mechanism controller that is usually used in industrial control systems. The second, LQR controller. LQR or linear quadratic regulator is one of the optimal control methods for state space-based systems. And the last, DC motor is a device that converts electrical energy into kinetic energy or motion. Next. please. These are the methods I used to create this paper. The first stage is to conduct a literature review related to the research conducted. The second stage is to model the dynamics of the DC motor on the PID controller so that the mathematical plan is obtained. And the third stage is to design a controller for the system. The fourth stage of application through simulation so that the response of the controller applied to the plan can be known. Fifth, testing and analysis to the implemented control scheme. And the final step of this research is drawing conclusion. Next, please. This is my flow chart that start from review of PID and LQR, then modeling the systematic of DC motor. After that, they calculate PID control using Rothe-Hurwitz method, then make PID simulation with MATLAB Simulink. If the simulation is failed, it's make unstable simulation and make change parameter PID with trial and error. If the simulation success, it's make the stable simulation. After got stable simulation, so we search the script or coding of LQR algorithm, then make LQR control simulation with MATLAB Simulink and enter the script that we made before. The result of simulation make two choice two. If failed, make the DC motor response is less fast and must to change to parameter Q and R. Then if success, make DC motor response if more responsive. And after form the responsive response of DC motor, we make result on conclusion and finish. Next. The formula that I use to calculation of gain margin and frequency merging using the Rothe-Hurwitz methods with the formula 1 plus kg times h equal 0, and the known equation is g is equal 10 k per 30 s power 3 plus 60 s power 2 plus 31 s. Next. This is the final known result have been entered in the table below. Next. So the result appears that the key is greater than 0, key is less than 31 per 5. So the result of gain margin is key equal 31 per 5 or equal 6.2. After knowing the gain margin, can be calculated frequency margin, and so on is 1.016 radian per second. So the control parameter can appear like in the table below. Okay, next. So after the calculate, we create diagram using MATLAB Simulink, and this is the diagram that I created. You can see. Next. This is the graph result of PID controller from the response above. It can be seen that the system is stable at 28 seconds. I'm sorry if the picture is too small. Okay, next. This is the method is used a benchmark, and then the trial and error method is used so that the system results are more optimal. With details, Kp equal 2.5, Ki equal 0.5, Kd equal 2.2. So the simulation design in MATLAB Simulink is shown below. Next. After change the parameter, it can be seen that the graph that appears after using trial and error is more stable than before. Next. This is just preview parameter that just I show you. parameter result and DC motor modeling using MATLAB Simulink. Next. This is the response result. Next. This is the graph result. Blue line depicts represent motor speed. Red line is represent current, and yellow line is represent position. And can be seen that on the graph that matrix R and has a better graph than the graph of Q. Next. From the graph seen on previous slide, it can be understood that the system response is not as fast as the system response when using the value of R equal 0.01. Next. And the last one is conclusion. It can be concluded that the DC motor is more stable and responsive than before controlling with PID method and LQR algorithm. The PID used with KP equal 2.5, KI equal 0.5, and KD equal 2.2. In the DC motor response system get a more optimal system than before. I got that from textbook of Ogata. The best system response is obtained when using the matrix value Q equal 1000, 00, 0, 10, 0, 0, 0, 0, and the value of R equal 0.01. Next. Enough from my presentation, and thank you.
Okay, what a great presentation from Fortuna Fiaza Habib Ainuddin. In his paper, he explained about optimal control of DC motor is designed using proportional integral derivative or PID method and linear quadratic regulator or LQR algorithm. And now we will open the question and answer session. If you have any question, please raise your hand and I'll allow you to unmute your microphone. Any questions are welcome. Okay, for Novario, the time is yours.
Okay, thanks for the time. Introduce myself. My name is Novario Padana. I'm from BBNS. I want to ask you, on the method slide, there are several methods. I think the 6 method. In your opinion, of the several methods above, which one is the most difficult to do? It's design or something else? Thanks.
Thank you for the question. So for the wait a second. For the 6th method, the difficult is on the to search the script or coding of the LQR script. Can you understand? I'm sorry, my language is too bad.
Yes, I know.
Okay, thank you.
Okay, thank you, Novario, for the question. And I will open one last question. If you guys any question, please raise your hand. Okay. Okay, there is Hanif. For Hanif, you can unmute your microphone and ask your question.
Okay, check. Okay, thank you, moderator, for the time. My name is Hanif from BPNS. What is the significance impact of your research for the community or environment? Thank you.
Okay, thank you for the question. I think for the how can I? Can you help me to translate to English?
Yes, sure.
Oke, jadi tadi pertanyaannya bisa diulang?
Yeah. Okay. For the question is, in Indonesia, apa dampak signifikan dari paper yang sudah Anda buat ini terhadap lingkungan atau sekitar?
Jadi itu berdampak untuk memperingankan dari semisal motor bekerja untuk mendapatkan posisi yang sempurna itu harus dalam kondisi yang cepat gitu. Jadi kalau terlalu lama itu nanti kayak kurang dari akan membuat kerugian sendiri gitu. Mungkin seperti itu. Terima kasih.
Okay, thank you. And then I'll try to translate it. So from this paper, the significance research for the community or environment is the result of this paper is hope to make it more easier for model work to get the right position in the fast time. Okay, I think that's all, Hanif. Is it clear or do you want to ask again?
Okay, is it clear? And thank you for the answer.
Okay, thank you, Hanif, for the question, and thank you for Fortuna Piazza Habib Ainuddin for the answer and the presentation. And we're doing due to limited time, so we need to moving to another speaker. And before that, again, thank you for Fortuna Piazza Habib Ainuddin for the presentation, and thank you for all of the questions. And then we're moving on to another speaker. It is from Muhammad Fikri Faturrahman, student from Shipbuilding Institute of Polytechnic Surabaya, with his paper titled Motor Speed Control with PID Control uses the metaphysical method LQR. For Muhammad Fikri Faturrahman, your time is 10 minutes and the time is yours.
Okay, thank you for the opportunity to speak at the International Student Conference. I'm Muhammad Fikri Faturrahman. I study at Shipbuilding Institute of Polytechnic Surabaya. My present here, I will present with the title Motor Speed Control with PID Control using metaphysical method. Next. Next. This is our dream. Back. Yes, thank you. This is our dream during the research. The first is Habibi Ahmad Bashari, a student merit electrical engineering study program at the Shipbuilding Institute of Polytechnic Surabaya. Coincidentally, he could not attend today. Then myself, Muhammad Fikri Faturrahman, a student marine electrical engineering study program at the Shipbuilding Institute of Polytechnic Surabaya. The last one is our mentor, Anggara Trisna Nugraha. He is a lecturer marine electrical engineering study program at the Shipbuilding Institute of Polytechnic Surabaya. Next. The first presentation is introduction, definition, discussion, conclusion, question and answer. Then the last one is closing. Next. First, introduction. Advanced in control technology are used in almost every industry in the world. Their car, motor, are actuators widely used in industry and control technology. The DC motor has a fast response, but has a steady state exertion. Therefore, we need a controller that matches the characteristic of the DC motor. PID is a fast response action controller suitable for controlling DC motor speed. In this role, we combine metaheuristic method from genetic algorithm to find optimal PID parameters compared to traditional PID methods used so far. To their low overshoot and much more efficiencies steady state velocity. Next. Do you know what method will be used in this time? This paper, the methods and tools used in this research are starting from DC motor control system, metaheuristic optimization, kinetic MATLAB modeling, and also PID. Then it will be explained briefly about it. The first, DC motor control system. The method applied to speed control DC motor is done in two ways, namely, one, anchor control. In this method, the motor speed is controlled by varying the armature voltage. And two, terrain control. In this method, the motor speed is controlled by varying the field current or starter current. Metaheuristic optimization method. Metaheuristic optimization refers to optimization problem using metaheuristic algorithm. Optimization is basically everywhere, from technical design to economic, from vacation planning to internet routing. Money, resource, and time are always limited. So it is very important to make the best use of this available resource. MATLAB modeling. From the system design described in the flow diagram and the mathematical model discussed in the previous chapter, we can begin to move on to realization in the form of simulation. Next. Kinetics algorithm is a probabilistic global research method that mimics natural evolutionary process. This is one of the methods used for optimization. John Holland officially introduced in this method in 1970 at the University of Michigan, USA. Continuous improvement in the performance of computer systems have made various optimization interesting. Kinetic algorithms start with no knowledge of suitable solution and completely depend on the response of this environmental and evolutionary operator, such as blending, crossing, and mutation to arrive the optimal solution. Next. PID consists of proportional, integral, and derivative action. We usually refer to the Ziegler-Nichols PID tuning parameters. This is the most common and widespread control algorithm. The PID control algorithm is mainly used in feedback loops. PID control can be implemented in various forms. Next. This is an experiment result. DC motor testing without PID. The research began by modeling on simulating in MATLAB and analyzing the response of the system without PID control. The table is a result of the response of DC motor without a PID control. Next. And two DC motor respond with PID tuning result with conventional methods. Then tuning is done with conventional method, namely the trial and error method with Ziegler-Nichols as a comparison of the optimization method that will be applied. Next. The following is a graph of the DC motor response resulting from PID tuning with 20 random population experiment. Next. Next is graph of the DC motor response with PID tuning result with 30 random population experiment. Next. And the last is graph of the DC motor response with PID tuning result with 50 random population experiment. Well, the three experiment graphs explain the genetic algorithm optimization, red color output, Ziegler-Nichols purple color output, and the last trial and error brown color output. Next. Conclusion. A settling time value of 1.30 seconds was obtained from testing in the control system using simulation on a PID control and tuning the genetic algorithm on a DC motor plant using 50 random population restricted to 60 liters. Proved to be longer as fast the Ziegler-Nichols method is 1.138 seconds and trial and error is 0.118 seconds. If the optimization is not limited to interaction and the optimization takes time, the result may be more optimal. Next. After presentation is finished, this time there will be a question and answer session. Please, if you have a question, you can ask us directly. Thank you.
Thank you. What a marvelous presentation from Muhammad Fikri Fatur Rahman. From the paper that he explained, it is about experiment, DC motor testing without PID and DC motor response with PID, showing results with conventional methods using 50 random population restricted to 60 liters, proved to be longer as fast as the Ziegler method. And now we will open the question and answer session. If you have any questions, please raise your hand and I'll allow you to unmute your microphone. Any questions are welcome. Okay, while waiting for the participant to ask, and I would like to ask to Muhammad Fikri Fatur Rahman. So from the paper that you already explained and presented, what's make your paper authentic? What's the difference your paper with another paper? Maybe you can explain it. Thank you.
Okay, thank you for the question. Give me as a minute to understand.
Sure. Okay, for Muhammad Fikri, are you done?
Okay, thank you for the question. In this paper, in this time in the industrial revolution 4.0, the control system is under industry plays the major role in increasing effectivities and efficiency in the production process. The control system for a plant in the system because the system consists of plants that form a production from production flow in the production system. This that's what I can answer. Thank you.
Okay, from your paper, we can know that because it is up to date with the needed of the Industrial Revolution 4.0 era. Thank you, Fikri, for the answer. And maybe for all of the participants, if you have any question, feel free to raise your hand and I'll allow you to unmute your microphone. Okay, because there is no more question. Thank you for Muhammad Fikri Fatur Rahman for the presentation and for the answer. And then we're gonna moving on to the next presenter. It is from Iain Duncan, student from University of Strathclyde, with his paper titled An Experimental Investigation into the Effect of Ventilation, Bulbs and Flow Turbulence on Flap Lifting T-fold Performance. For Iain Duncan, your time is 10 minutes and the time is yours.
Thank you very much. So the flap lifting T-foil that was selected is from the Wasp, which is the small sailing dinghy that you can see at the bottom of the picture. The lifting T-foil is normally used as the rudder and supports some of the boat's weight when it is head profiling. It was selected for several reasons. One, it was available in the lab for existing projects that have been undertaken by a PhD student, but it's also known to have significant issues with ventilation. We can see that flap lifting T-foils appear in a large range of applications, commonly seen in sailing dinghies at the minute to allow boats to be lifted clear of the water, but we're also seeing lifting T-foils being used in high-speed craft to control motion and lead to improvements in seakeeping. Tank testing was the selected methodology. There was approximately 600 runs done in various configurations of the foil across 3 separate weeks, with previous work being undertaken as well, which was used to show that the rig was successful. This was selected because simulations involving ventilation are very challenging due to the fact that we have multi-phase flow. The foil was tested at a range of submersion depths, yaw angles and speeds, with pitch, roll and flap angle maintained as a constant throughout the project. Initially, a water sprayer was used. The spray was aimed at the junction between the strut and the free surface of the tank to cause ventilation. This was due to the tank testing speeds not allowing a realistic Reynolds number to be achieved. The foil was tested at approximately half of its max operating speed, and the foil was tested at the speed it's likely to be operating at when the vessel transitions from buoyancy to lift support. As you'll see later on, a new ventilation triggering method was developed as part of the project, leading to better testing being possible in the future. The foil was modified in 3 ways. You can see the unmodified foil on the left-hand side. We then fitted a bulb to the foil. This moved the horizontal backwards away from the strut and up relative to the unmodified foil. And you can also see on the right-hand side that the strut has a turbulence generating wire fitted to it. The strut was tested on its own with this turbulence generated wire. It was tested with the unmodified foil with a wire, and it was also tested with the bulb as well. We can see that ventilation forms, it starts at the top, generally working its way down the foil. It occurs when the flow is separated from the strut and is significantly more likely when we have a yawed foil due to low pressure regions that form down one side. We know that the ventilation will only occur when there's a path from the atmosphere to underneath the free surface, so the free surface must be broken. We know that flow separation has to occur as well, and that is a key element of why the water sprayer and the wire work. A new ventilation triggering methodology relies on the fact that the turbulence generating wire increases the flow turbulence. This then leads to the flow separating from the foil. When we tested the strut on its own with turbulence generating wire, we saw tip vortex ventilation. You can see that there is a vortex leaving the tip of the strut in the image on the right-hand side. Tip vortex ventilation allows ventilation to occur when the vortex that comes off the tip of a structure is large enough that air can pass down it, leading to full ventilation. This was only seen as the mechanism of ventilation for the strut. Otherwise, we saw something called free surface filament vortex ventilation. Our new triggering methodology was capable of triggering ventilation for the strut, the unmodified foil, and the foil with the bulb. We saw that the position of the wire was quite important. The wire was tested at a range of positions on the strut, starting at 10 millimeters from the leading edge of the strut back to 50 millimeters. Ventilation was more stable with a wire 30 millimeters from the leading edge. Ventilation didn't occur 10 millimeters from the leading edge unless the water sprayer was used as well. And the images on the right sequence shows the development of ventilation before it then collapses. This was common with a wire 50 millimeters from the leading edge. Testing with a wire further back may be interesting because it's possible that ventilation does not occur at all. We can also see in the images in the bottom a difference in the cavity at the very back of the ventilated cavity, the sort of turbulent structure in the image on the right. This was occurring depending on the position of the wire. So when we moved the wire a little bit further forwards and caused ventilation with the sprayer, we saw this turbulence coming off the junction between the strut and the horizontal. When it was a little bit further back, we saw that the cavity was much clearer. So here the position of the wire is quite significant in affecting the behavior of the ventilation. We see that the further away we get from the strut, the smaller the ventilated cavity gets. It is almost a diagonal shape, so it rises towards the free surface. In a small number of cases, in the black and white image at the bottom, you can see the horizontal. We can see that there's visible ventilation on it. This was not something we saw repeatedly, but it did happen in a small number of cases. Most likely to occur when the wire was fitted close to the foil, when we used the water sprayer and the wire together, and at low submergence angles. Further work's required to explain exactly why this occurs in some cases and not others. What we were generally seeing though was the ventilation was occurring closest to the strut and moving out the way in an unstable fashion with flashes, before either becoming totally stable, like in the image shown, or it decayed away to nothing. These results are presented for fully wetted flow, no ventilation occurring. What we can see is that moving the horizontal behind the strut when the bulb is fitted leads to a significant improvement compared to the unmodified foil. This is due to the horizontal operating in a low pressure region behind the strut, increasing the pressure differential. We see that lift varies with the depth of submergence. Interactions occur with the free surface, which affect the effective angle of attack of the fluid over the horizontal. This affects the lift. We see that fitting the wire when we fitted the bulb also leads to an improvement in performance. The wire increases the low pressure region behind the strut, increasing performance further. It is clear though that the wire to the unmodified foil without the bulb does not lead to improvement. This is the lift drag ratio for the same set of results. What we can see is that in some cases, the lift drag ratio is improved substantially by the bulb and the wire. No attempt was made to optimize the shape of the bulb to reduce drag. So I would expect that if we conducted further work on the shape of the bulb, we could get a further improvement in the lift drag ratio. We found that yawing the foil leads to an increase in lift in all foil configurations. This is due to the connection between the low pressure region down the side of the structure to the yawed foil and the low pressure region on top of the horizontal. You can see in these images here a visible difference in the interaction between the horizontal and the free surface. You can see that at the lower submergence depth, there's a larger kind of bubbly aerated region that forms behind the strut. It's possible that this is evidence that supports the theory of the wave behind the strut, leading to the deflection of the fluid. This has been quite well modeled by other researchers with CFD, and it's not something that we have done a significant amount of work on, though our results do fit with other people's. These results are presented for fully ventilated flow. What we can see is that ventilation results in a significant lift reduction. When the ventilated cavity forms, it forms atmospheric pressure. This is a higher pressure than the top surface of the horizontal, which is known as the suction side. This rise in pressure on the suction side of the horizontal leads to a decrease in the pressure differential across the horizontal, and hence a decrease in lift. When we fit the bulb removes the horizontal from the visible ventilated cavity, as we can see in the image at the bottom right, And this means that the foil continues to produce a positive lift throughout the interaction. So it's clear that it's a very simple modification we can make that improves the performance of the foil in fully ventilated. Significant further work should be done on optimizing the bulb shape, trying to reduce the drag. Other work should be done to optimize the position of the horizontal, moving it further up, further into the low pressure region behind the strut be beneficial, for example. This requires work. Quantifying the flow turbulence would be useful, and testing a greater range of wire positions and potentially different diameters of wire or different shapes of turbulence generator would be useful too. Finally, we haven't done very much work on realistic sailing operating conditions. For example, boats very rarely sail at 0 degrees of heel. So testing at heel angle would be useful. Testing at pitch angle would be useful. And testing in scenarios that are likely to represent the, likely to cause the visible ventilation on the horizontal would be useful as well. If you'd like to ask any questions, you're welcome.
What a fabulous presentation from Ian and Duncan. And now we will open the question and answer session. If you have any questions, please raise your hand and I'll allow you to unmute your microphone. Any questions are welcome. For Ajeng, you can unmute your microphone and ask your question.
Okay, before I want to ask something, let me introduce myself. My name is Ajeng Busmaningtyas from PPNS, and I want to ask you, do you think that the water conditions such that depth will also affecting the T-foil ventilation performance? Thank you.
Yeah, work done by researchers Jonathan Binns in Australia show that depth of submergence of the foil has a direct impact on the probability of the foil ventilating.
Okay, is it enough for Ajeng or do you want to ask again?
I think it's enough. Thank you.
Thank you, Ajeng, for the question. And then if there is any more question, you can raise your hand and I'll allow you to unmute your microphone. Okay, for Bagas, please ask your question. You can unmute your microphone first.
Thank you. My name is Bagas Rahmat from PPNS. I have some question, Mr. Ian Duncan. How do you make your product for stay reliable? And if you want to sell this product, what is make your product is perfect than other? Thank you, Mr.
Can you just ask again about selling the product from me? Just expand a little bit on that.
Can you repeat? Okay, Mr. I repeat this my question. How do you make your product for stay reliable? And if you want to sell this product, what is make your product is perfect than other?
Okay, so the actual hydrofoil itself is already commercially available. We've tested a commercially available hydrofoil, and the only bit we manufactured ourselves was the bulb, which was just a straightforward metal tube that reminds me of scaffolding tubing. It's quite a long way from being something that would be commercially viable. You'd have to do significant work to optimize its shape and optimize the position. It's very much a kind of initial concept. On the sort of sustainability side, I can see that an improvement in the lift drag ratio is going to be quite useful for reducing fuel consumption on vessels. If you can produce the same lift with a smaller foil, you're immediately reducing friction drag, for example, which we're always looking to do, obviously, as designers.
Thank you for the answer. How about it, Bagas? Is it clear or do you want to ask again?
Thank you, Mr. Ian Duncan. It's enough.
Okay, thank you for the question. And maybe I would like to ask too, for your research, would you mind to tell us, maybe you can want to improve your research more, what do you want to do next?
What we want to do next, we would like to test the horizontal in more positions to find the optimum one. I'd also like to test the horizontal in front of the strut to see what effect that has, because I suspect that that will improve its performance in a ventilated state compared to the unmodified foil. It would also be really good to be able to create accurate CFD simulations that would let us optimize the shape of the bulb quickly without having to use experimental testing.
Okay, that was great. Good luck on your next research. Okay, to our limited time. Thank you for all the questions for all the participants, and thank you for Ian Duncan for the presentation. Okay, thank you. Now we're going on to continue to our next presenter. It is from Alvina Putri Aulia, student from Shipbuilding Institute of Polytechnic Surabaya, with her paper titled Determination Light Ship of the 15 GD fishing vessel through the rolling period test. For Alvina Putri Aulia, you have 10 minutes and the time is yours. For Alvina Putri Aulia. For Alvina Putri Aulia, the time is yours. Okay, we're sorry. I think there is connection problem for Alvina, our next presenter. Please wait for a while. Okay, due to connection problem for Alvina, We're gonna move to another presenter. It is from Salsabila Eka Yuniza, student from Shipbuilding Institute of Polytechnic Surabaya, with her paper titled Power Quality. For the paper title is three-phase uncontrolled half-wave rectifier from three-phase AC generator. From Salsa, your time is 10 minutes and the time is yours.
Okay, thank you. Is it my voice audible?
Yes, it is audible.
Okay, thank you. I will start my presentation in 3, 2, 1. Next. Ladies and gentlemen, we know that the demand of electricity are forecasting to be increased until 77.3 gigawatt in 2030, especially in the industrial field. There is a lot of equipment that use electricity as main power to operate. In various industrial machines require different power and different specifications. Besides, the use of electrical is not only in the industrial field, but also in the transportation, such as in the ships. Electrical system on ships can be said to be a small scale of an industrial power system. The ship's electrical system currently use a medium voltage of 3.3 kilovolt to 6 kilovolt. Next. And the use of power semiconductors and integrated power electronic application in the ship's propulsion system, which using DC voltage, raises several power quality problems, especially in the ship's electricity. It is usually called as harmonic distortion. Harmonic distortion is a condition when there is excess harmonic caused by the use of power electronic equipment, such as inverter, substarter, switch, model power supply, and so on. And what is the consequence of this power quality problems? The first impact of this problem is it will interfere with some electronic equipment that is sensitive to electromagnetic interference. And the second problem is it will increase the reactive power, or usually called as reactive losses. And the third problem is the occurrence of insulation stress. So the cable insulation and electrical equipment insulation is getting broke. And the fourth problem is the resonancy disturbance will be increased. And the last problem is electromagnetic, it will create electromagnetic disturbance. So based on this problem, it also created impact, which is especially in the power voltage and current stability. And how to handle that? Next. Good afternoon, the honorable judges and audience in this conference. I'm Salsabila Eka Yuniza from Marine Electrical Engineering Study Program PPNS. Will be present paper about next. Three-pass uncontrolled half-wave rectifier from three-pass AC generator. Next. Okay, and this rectifier purpose for convert AC voltage to uncontrolled DC voltage, so that it can help the user, especially for machinery control, to avoid from power harmonic that will be disturb the performance of control system if it is not handled well. And in this research, I use the methodology which is participatory observation. This method is type of data collection method that is usually carried by connecting our positioning researchers to act directly as observers and also as implementers of something to be observed. Researchers in this paper will obtain data from the experimental results of the magnitude of the current, the magnitude of the voltage, and also the amount of power that has been obtained from the rectifier circuit. And this rectifier circuit comes from a three-pass generator. And the purpose of this measurement is to find out how effectively the rectifier circuit flows to the load. And then the simulation in this research is using PSEN software to simulate rectifier circuit. And the testing result will be compared with the manual calculation to find out that the formula that already exists in our books, textbook, and much more is
proper to use and can be evaluated for the further design of rectifier circuit. Next. And we are going to the result and discussion, which is here the circuit simulation of 3-pass uncontrolled half-wave rectifier. In the picture 1, so that the circuit use 3 diodes because we wanted the output is half-wave DC voltage. And then the circuit, of course, has a variety of components. The following are components installed in this experiment, such as alternator, resistor, diode, voltmeter, and ammeter to know what is the result. And these components are installed in such a way as to form an uncontrolled 3-pass rectifier, which is supplied by a 3-pass synchronous generator. Then the simulation result is on the picture 2. The result so that the rectifier are successful to convert AC voltage to DC voltage. And the result is uncontrolled DC voltage. It means the user cannot control the load power that created by the circuit. Next. And then this is the data result. From the simulation, we use 5 variations of voltage source starting from 50 until 150 volts. And the variable of the result is voltage output by measurement and RMS voltage output. Both variable is compared in the theoretical and practical results to know the accuracy between the formula and simulation. And from the data, know that the average accuracy of voltage output, or usually called as VO, is 99.80%, and VO RMS is 99.50%. So it can be concluded that from the percentage, it means between the formula and the simulation is have a great accuracy with small differences. So it is proven that the simulation in the textbooks is ready and proper to use in the further research. And next. Next slide, please. Okay, here is the conclusion of this paper. The first conclusion is the rectifier circuit in the simulation, it already proven the function to convert AC electric current to DC RT current, so that it can be implemented on the machine and control system that use DC voltage. And the second conclusion is the important thing in the rectifier system is the usage of diode component. The component has a function to block one direction of electric current. And the last conclusion is for the further research, the rectifier should be implemented and tested to get more detailed result, and then the circuit can be combined with a capacitor to decrease or erase the ripple that created by converter. And then if it use capacitor, it can create a clear DC voltage converter and can support the performance of system in the DC machinery. And next. Okay, I think that's all from me about the presentation. Thanks for your attention.
What a great presentation from Salsabila Ika Yuniza. Before the Q&A session, I encourage all the participants to feel free to ask, because there will be special reward for the most active participant. And now we will open the question and answer session. If you have any questions, please raise your hand and I'll allow you to unmute your microphone. Any questions are welcome. Okay, for Ajeng, you can unmute your microphone and then tell your question.
Okay, before I start, let me introduce myself. My name is Ajeng Musmaning Dia. About
Sorry, I think there is connection problem. Maybe you can tell again your question.
Okay, let me repeat my question. What is the significance of your research for the community or environment? Is it clear?
Yes, I think it is clear enough. For Salsabila, you can answer the question.
Okay, thank you, Ajung, for the question. So, our question is, what is the significant result or significant effect to the society? And I will answer that. The significant impact is its purposes, especially for the industries and the ships industry, which is those rectifier can be used in the ballast control system, so that it will help all of the people there to have a proper and greater circuit to control the ballast system. I think that's all from me. Thanks.
Thank you for the answer. How about it? Is it clear, Ajeng, or you want to ask again?
It's clear. Thank you.
Anytime. If there is any question again, please raise your hand and I'll allow you to unmute your microphone. For Hanif, you can tell your question.
Okay, thank you. Hello, my name is Hanif from PNS. Do you have any idea for the next research to continue your current research? Thank you.
Thank you for the question for Hanif, and then Salsa, you can answer the question.
Okay, Hanif, thank you for the question. For the further research, I wanted to implement all of this rectifier simulation on the real motor DC. So on the real motor DC control, which is if I implement it, it will know what is the detail, what is the problem, and what is more that should be improved in the next research. So I think it will I do in the next research.
Thank you for the answer. I think that's clear enough. And due to our limited time, we are going to close the Q&A session. Thank you for all the questions for the participant, and thank you for Salsabila Ika Yuniza for the presentation. Ladies and gentlemen, before we continue to the next presenter, we will have a short break for about 15 minutes. I'll give it back to Aura as the master of ceremony.
Thank you, Aida. Ladies and gentlemen, we will have a break for 15 minutes. Please be reminded to come back at 17:15 WIB or 11:15 at Glasgow time. Thank you. Okay, ladies and gentlemen, now we already come back into our conference. Please make sure that your camera is already open and put your microphone off as we continue our presentation, and this session will be moderated by Aida Nelawati Rosa as our moderator. Now the time is yours.
Thank you, Aura. Good evening, ladies and gentlemen. Welcome back with me, Aida Nelawati Rosa. And now we're going on to continue our presentation session for the next presenter. It is from Alvina Putri Aulia, student from Shipbuilding Institute of Polytechnic Surabaya, with her paper titled Determination Lightship of the 15 GT Fishing Vessel Through the Rolling Period Test. For Alvina Putri Aulia, your time is 10 minutes, and the time is yours.
Thanks for the time. Can you hear me?
Yes, you are audible.
Good evening, ladies and gentlemen. Thank you for your time to join this conference. It's an honor to be stand and speak in front of you. First of all, let me introduce myself. My name is Alvina Putri Aulia from Marine Engineering Study Program of Shipbuilding Institute of Polytechnic Surabaya. In this great opportunity, I will to present my paper with the title Determination Lightship of the 15 gross tonnage fishing vessel through the rolling period test. Next. The background of this paper is the 15 gross tonnage fishing vessel is a vessel that represents non-conventional small vessel operating in limited Indonesian water. The most of the non-conventional small vessel built in 15 gross tonnage fishing shipyard didn't pay attention to ship stability, especially when the ship drawings and stability calculation don't match with the actual condition of the ship. The ship stability report is also not equipped with an inclining test report or postal weight calculation because it's constrained by relatively expensive cost and limited availability of equipment, so that the stability report does not approach the actual ship condition because the weight and center of gravity of the ship cannot represent the weight and center of gravity of real vessel. This can increase the potential for stability failure caused by an accurate determination of lightship value. Therefore, this study aims to determine the lightship on a 15 gross tonnage fishing vessel through a rolling period test. This method is based on the standard of the Indonesian Classification Bureau Policy of 2003 concerning instruction for testing vessel tilt and rolling period of vessel. This test procedure is carried out to obtain carefully the weight and location of the center of gravity of the vessel an empty condition to meet the requirement of Indonesian Classification Bureau and also to fulfill statutory requirement for government agency. Next. And then the study ship from this paper is rolling period test is one of the tests to determine the stability characteristic of small vessel. Rolling period test is a simpler way to determine the initial stability of a ship than the inclining test. The rolling period test must be carried carefully because the stability check with the rolling period only measure the metacenter point and does not consider the return moment. Estimate metacenter height can use the following formula. The first formula according to the Indonesian Classification Bureau. The second formula using coefficient according to the International Code on Intake Stability, and third formula using the radius of gyration. According to the evaluation result of several calculation of metacentral height on inclination and swing test, the third formula is used because it gives the best result. Next. And then the research methodology of this paper is the ship can be made to rolling by pulling and pushing one side of the superstructure so that the ship rolling according to the specified tilt angle, which is a minimum of 9 degrees. Recording begins at the time of the rolling at the point with the greatest angle. After the rolling is complete, this operation is repeated again From a number of result of recording the rolling period, the average value is taken, which will be used as a number for calculation. The recording of the time and number of swings can only be started when the ship has actually swung freely and naturally, and the number of swings that can be recorded, observation and recording of the time is carried for 5 oscillations. This is done by 2 people, 1 person on the ship and 2 people and the second person on the port. The rolling period test is carried to determine the weight of the empty ship through a draft survey on the bow and the stern. Next. The result of rolling period test of this paper is the draft survey is the stage before conducting a rolling period test in the field, which aims to determine the empty weight of a 15 gross tonnage fishing vessel. In this research, draft measurements were carried at the bow and stern of the ship on the port side and starboard side of the ship. At the time measurement, the ship was in a stern trim condition of 0.54 meters, and in the calculation of the water draft correction is carried to the stern draft mark to the aft perpendicular and the bow draft mark to the forward perpendicular, with the respective distance between the draft mark to aft perpendicular and forward perpendicular are 2 meters and 15 meters, so that the water laden correction result in a trim value of 0.687 meters, and the result of the correction of the water laden measurement are analyzed on maximum stability with specified condition, so that it's known that the empty weight of the 15 gross tonnage fishing vessel is 14.79 tons. Next. After conducting a full survey, the next step is to make preparation before carry out the rolling period test. The first preparation is make sure the weather. The test was carried out on the edge of the pier with good weather condition because the wind speed during the test was less than 4 knots. When speed during testing is measured using an anemometer, where the measuring instrument show a number of 0.8 meters per second or equivalent to 1.944 knots. And then the second preparation is measure the initial tail position of the ship. According to the rules of the Indonesian Classification Bureau, the permissible inclination of the ship in the initial position does not exceed 0.5 degrees. The ship initial inclination position of 0.4 degrees is measured using a digital inclinometer. And then the next preparation is make sure the mooring on the free tension condition. According to the rules of the Indonesian Classification Bureau, mooring ropes for 15 gross tonnage fishing vessel must be tension-free and the water depth below the hull is sufficient to ensure that the hull is completely free from the bottom of the water. The next preparation is make pendulum and equipment. In the rolling period test, using a pendulum, a protector, and a rope used to hang the pendulum at the front. This equipment is used to measure the degree of inclination during the rolling period test. The length of the rope is 0.5 meters, placed at the 0.259 point measure from the aft perpendicular point, and the total weight of the pendulum and its equipment is 0.035 tons. The next preparation is make sure all tanks must be empty of fuel. The number of tank filled should be kept to a minimum, and then in the rolling period test of 15 gross tonnage fishing vessel, the tank is empty, so it's not necessary to calculate. And then the last preparation is make a list all goods that are raised, lower, or relocate must be recorded carefully. The total weight of the goods raised and unload from the ship is 0.07 tons, with line center of gravity is 14 meters and vertical center of gravity is 1.724 meters. Next. In this slide, show the result of rolling period test. The result of recording the period on the rolling period test and the ship metacentral position can be known through the period required for one oscillation when the ship is rolling, or can use that formula using the radius of gyration to get the value of metacentral height for each record period. The data for that period has been validated by testing 5 times so that the data obtained is homogeneous, so that the result standard deviation is 3.72%. Next. Next. So the metacentral height of 15 gross tonnage fishing vessel obtained from the result of the rolling period test is 0.595 meters based on the metacentral height, and then it can be seen the location of the center of gravity of the 15 gross tonnage fishing vessel. Next. So the conclusion of this paper is the rolling period on a 15 gross tonnage fishing vessel was carried by rolling the vessel and then recording the time period required for one oscillation. Time recording is carried 5 times for each oscillation test, while the test is also carried 5 times. Based on the rolling period test, the value of the 15 gross tonnage fishing vessel like ship is 14.79 tons with a longitudinal center gravity is 6.139 meters. Vertical center of gravity is 1.217 meters and transversal center of gravity is minus 0.001 meters. Next. And then the acknowledgement of this paper are supported by a lecture from the Institute of Polytechnic Surabaya and lecture from the Indonesian Classification Bureau. Next. Okay, this is all I can say. Thank you for your attention.
An incredible presentation from Alvina Putri Aulia. From paper that she explained, we could know about rolling period test on a 15 GT fishing vessel that carried out by rolling the vessel and then recording the time period required for one oscillation. And now we will open the question and answer session. If you have any questions, please raise your hand and I'll allow you to unmute your microphone. Any questions are welcome. For Salma Agatha, you can unmute your microphone and then tell your question.
Okay, thank you, Mrs. Aida, and thank you for your time. My name is Salma Agatha. I would like to ask to Mrs. Alvina. Alvina, as a writer of the paper, you got any trouble while doing the study? And what is the result of this study? Thank you. That's all right.
Thank you for the question. For Alvina, you can answer the question.
Thank you for your question. The trouble when carried this rolling period test are the presence of external influence such as current, wind speed, and the use of an adequate period measurement tools. And also this test ignore the return moment. So I have to do several times of testing to get homogeneous data. And then the result of this research is the rolling period test can be used as an alternative for determining the light shape value of the inclining test can be carried on small ship because the rolling period test is easier to do at an affordable cost. Thank you.
Thank you for the answer. How is it about for Salma? Is it enough or maybe do you want to ask again?
Okay, thank you, Aida. Thank you for Alvina for answering my question. I think everything is quite clear and all right. Thank you.
Thank you for the question. And then next, if the participant have any answer, feel free to ask. You can raise your hand and I'll allow you to unmute your microphone. Okay, due to our limited time, we apologize that we only limited to one question. So we're gonna move on to the next speaker. Before that, thank you for the question and thank you for Alvina Putri for the presentation. And now we're going on to continue to our next presenter. It is from Diego Ilham Yoga Atna, student from Shipbuilding Institute of Polytechnic Surabaya. Your time is 10 minutes. The time is yours.
Okay, thank you for the time and also the opportunity that has been given. Before we move on the topic of discussion that I will bring in this presentation, next. Okay, let me to introduce myself. My name is Diego Ilham Yogakna and I'm from Marine Electrical Engineering Study Program. That was a brief introduction from me. Then let's go straight to the topic of the presentation that I broke this time with the title next. Sorry, next. Okay, three-phase uncontrolled full wave rectifier from three-phase AC ship generator. Okay, next. The development of the time has caused many changes in various aspects. The aspect that is developing rapidly is the technological aspect. Technology can no longer be separate from human life because the nature of technology itself directly facilitates human life in various fields. The technology that was created along with the times, of course, the composition of the electrical component also developed. With good optimization will make a circuit work more effectively and ergonomically than before. Focusing on three-phase electricity, which is often used in machinery, especially generators, is an important topic that is good to be studied more deeply, so that its users are better. With a good study and the success of the study will produce results in the form of progress in the use of electricity due to optimization. Next. Generator is a device to produce electrical energy that is able to convert a movement or a mechanical energy into electrical energy. The generator is capable of moving to produce electric power in the form of alternating or commonly called AC, and also capable of producing direct electric power or commonly called DC. This is adjust to the needs of the generators itself. But in the condition that the generator produce AC electrical power, the generator is also called an alternator. In moving the generator using the theory of Faraday's law theory, and also supported by Lenz law. The generator is in its action produce a movement in the form of rotation. The rotation that occurs in the generator is powered by full and the form of diesel by moving the generator in the form of a chopper coil in the form of a wire consisting of a static coil or stator and also a rotating coil or rotor. This generator rotation utilizes a magnetic field to generate electricity by utilizing Faraday's law and Lenz's law. Next. Generators are broadly divided into two parts, which are distinguished by the way they are driven, namely moving parts and immovable parts. The moving part is referred to as the rotor part, and the stationary part of the generator is referred to as the stator part. Next. Data analysis in this study is to make an orderly sequence, manipulate the amount and abbreviate the data so that it is help that it will be easy to read later for review. This research use PSIM software, which is software that focus on virtual simulation design for power electronics, motor drives, and power conversion system. Next. The following is a simulation of a rectifier circuit that is used to convert the source voltage in the form of a AC or alternating into DC in the form of unidirectional. Next. And the next is the conclusion of the research, namely AC generator can be converted into DC electricity using a rectifier circuit. Then DC diodes are semiconductor components that are capable of closing one direction of electric current into one direction. So that converts AC power into DC. And the last, the rectifier circuit can be used effectively with the help of capacitor to eliminate ripples in it. Next. Thank you. That's all for my presentation. Maybe there are questions or addition.
What a great presentation from Diego Ilham Yoga Agna. Before the Q&A session, I encourage all the participants to feel free to ask because there will be special reward for the most active participant. And now we will open the question and answer session. If you have any questions, please raise your hand and I'll allow you to unmute your microphone. Any questions are welcome. For all of the participants, if you have any question, you can raise your hand. Okay, while we are waiting for the participant to ask, maybe I would like to ask for Diego Ilham. For your research, maybe do you have any idea to explain to us or to tell to us for what the next research you want to continue based on your current research? For Diego Ilham, you can answer the question.
Okay, thank you for a question. My answer just short. Just for the research, I will implementation it. Okay, that's all.
Okay, what a great answer for Diego Ilham. Good luck on your next project for implement this research. For all of the participants, if you have any question, please raise your hand, and then I'll let you unmute your microphone. Okay, while we're waiting for the participants to ask, maybe I would like to ask one more time again for Diego Ilham. So for this research, maybe do you want to share what's the challenge and maybe how you overcome the challenge in this research?
I'm sorry. Maybe can I have a minute?
Sure, take your time.
Okay. Thank you. Maybe my answer is for this research is not too difficult for me because there are already studies on half wave from Salsabila. Maybe that's all.
Okay, thank you for your answer for Diego Ilham. And due to our limited time, I think we can close the Q&A session for Diego Ilham presentation. Thank you for Diego Ilham Yoga Agna for the answer and for the presentation. Ladies and gentlemen, before we continue to the next presenter, I'm Aida Nalatirasa as the second moderator will signing out. And there is my partner who will continue to lead the presentation session. I do apologize if there is any mistake by me in leading this presentation session on International Student Conference 2022. Thank you very much. Hope we all can meet at another change. And back to Aura as the master of ceremony.
Thank you, Aida, to take lead of our fabulous presenter. So are you. As the following presentation, now we have our last moderator, the analyst. Please welcome Ajeng Puspaning Tias, a student from Piping Engineering Study Program in PPNS. The time is yours.
Okay, thank you, Aura. Good evening, ladies and gentlemen. Now you're with me, Ajeng Puspaning Tias, as the third moderator of International Student Conference 2022 that's hosted by Shubuding Institute of Polytechnic Surabaya in collaboration with University of Starlight Glasgow. Just like before, in this presentation session, there will be held for 10 minutes and continued with question and answer session for 5 minutes for each participant. Now, without any further ado, let's continue with our next presenter, Zahrani Putri, with the title is Feasibility Analysis of Yellowfin Tuna Cultivation with Offshore Floating Cages in Sanghi Waters to Increase Export Value. Zahrani Putri, the time is yours.
Test. Can you hear my voice?
Yes.
Okay. Thank you so much for the time. Good evening, ladies and gentlemen. I'm glad to see you all at this conference, and I hope all of you in a good condition. First of all, let me introduce members of this team. First, there's Wanda Anissa Awalia. Second, there's Dian Ajeng Rahmawati. Third, there's Maulidina Rahmawati. Fourth, there's Kania Sasa Aryawan. And the last is me, Zahrani Putri Amalia, as speaker of this team. And we are from the Shipbuilding Institute of Polytechnic Surabaya, majoring in the Business Management Department. On this nice occasion, I would like to present the result of our research under the title Feasibility Analysis of Yellowfin Tuna Cultivation with Offshore Floating Cages in Sangihe Waters to increase export value. Hopefully, my presentation will act as a springboard for discussion. Next slide. Next slide. At first, since tuna is one of Indonesia's mainstay fishery commodities that has high economic value, Indonesia ranked first in 2014 with a share of 17.8% of the total world tuna catches of more than 1 million tons. The distribution of tuna is strongly influenced by temperature and water depth. Temperature and water depth are very important to support the success of tuna fishing operations. Environmental factors surrounding the waters also affect the horizontal and vertical distribution of tuna. Aqua, the next slide. Next slide. Next slide. Aquaculture has become a rapidly growing industry due to the increasing demand for export. I'm sorry, before going to before slide. Turn back. I'm sorry. Yes. Aquaculture has become a rapidly growing industry due to the increasing demand for export. Offshore floating cages activities can take advantage of public seawaters, which are not used in the location around the farmer's residence, so there's no cost to rent or buy cultivated land. In addition, for feed purposes, they usually only use fish left over from the catch that have less value for sale. Next slide. So we hope offshore floating cages become a solution to increase tuna fish production. Next slide. Yeah, about our research method. Next slide. First is descriptive analysis. The data collected is secondary data in the form of data on the distribution of tuna caught in the Indian Ocean and water quality obtained from previous research at one location in Sangihe waters, North Sulawesi, namely the Kalakeng Beach. Then about the study literature. The results of various literature search are used to identify the feasibility of yellowfin tuna cultivation using offshore floating cages in Sangihe waters to increase export value. Next slide. Then about our result and discussion. Next slide. First discussion is distribution of carp tuna. Tuna is a type of pelagic fish which in its royal group will appear above the thermocline layer before sunrise and when the sun will set in the afternoon. Tuna caught in depth strata have a different size dominance. Based on observations, at a depth of 0 to 100 meters of yellowfin tuna caught, 70% were dominated by fish measuring more than 100 centimeters, while at a depth of 100 till 200 meters, 88% were dominated by size more than 100 centimeters. And tropical waters are a suitable area for catching yellowfin tuna, either close to the island or something distance away. Next slide. Yeah, the next is salinity. Salinity at Kalakeng Beach, Sangihe Waters, North Sulawesi, reached a value of 30.2 part per thousand. This result indicates that the selected location in a position closer to high seas, so it's able to minimize the influence of the freshwater input. Freshwater has a low salinity value, generally less than 3, while seawater has a salinity value above 33. Next is temperature. From the previous research, so the optimum temperature for fish cultivation is around 27 till 32 degrees Celsius. Temperature at the Kalahem Beach, Sangihe Water, North Sulawesi reached around 29.1. So these waters are suitable as a location for fish cultivation with offshore floating cages. Next is dissolved oxygen. For the growth of marine fish, a minimum dissolved oxygen content of 4 mg per L is required, while the optimum content is a high as 5 till 6 mg per L. Oxygen at the selected location is measured in the range of 5.8 mg per L, so the level of dissolved oxygen in this water is very visible to support the life and growth of the fish to be cultivated. Next slide. Next is water brightness. The result of observation of the brightness of the selected location are at 3.7 meter. This proves that the selected location has a suitable brightness to be a location for tuna cultivation with offshore floating cages. It's because this location has a bottom substrate of sandy coral waters. The next is decrease of acidity, and we call it pH. pH at the selected location has a value of 7. This location has a suitable pH level as a location for fish farming with offshore floating cages. And the next is the sea depth. The depth of the Sangihe water can reach more than 5,000 meters above sea level. For fish farming in offshore floating cages, the minimum water depth is determined by the dimension of the neck pocket, tidal difference, and the minimum distance between the pocket and the bottom of the water. Getting around shallow waters can be done by reducing the height of the net bag so that the cage distance to the bottom of the water can be obtained by 1 meter. And the last is current speed in the water. The current velocity in Sangihe water is around 23.95 centimeter per second. These waters have a good current velocity for fish farming activities with offshore floating cages. There will be more sticking organism in the net if the current velocity is below 25 centimeter per second, so that it will reduce water circulation and dissolve oxygen. But a good current velocity for cultivation in offshore floating cages is around 5 till 15 centimeter per second. Okay, for the last, next slide. Next slide. Yeah, in conclusion, it can be said that as a water area, there is a migration route for pelagic fish, especially for the type of tuna. Sangihe waters is very strategic area, and it's not a risk to be used as a location for yellowfin tuna cultivation with offshore floating cages. Next slide. I think it's enough for me. Thanks a lot for listening to my presentation. May all those we've shared be beneficial for all of us, and I give it back to the moderator. Thank you.
Okay, thank you. What an excellent presentation from Zarani Putri. Now we're going to question and answer session. For all participants who want to ask a question, you can raise your hand and unmute your microphone. Okay, from the first participant, Mr. Miftah, you can unmute your microphone.
Okay, well, thank you so much. Uh, it's wonderful presentation, I think. What I want to ask here is about why do you choose yellowfin tuna, not the other fish, for your observation?
Okay, for Zahrani Putri, you can answer the question.
Hello, can hear my voice?
Yes, we can hear you.
Okay. Thank you so much for the question, Mr. Miftah. So, why we are choose yellowfin tuna, not the other fish? Indonesian Minister of Maritime Affairs and Fisheries Sharif J. Sutarjo explained that yellowfin tuna, which has a high economic value in the high market and has been successfully cultivated by the Gondol Bali Research and Development Center for Marine Cultivation. And judging from the nutritional composition, tuna has extraordinary nutritional value. The protein content in yellowfin tuna is almost twice the protein content in eggs, which is known as the main protein source. Protein content per 100 grams of yellowfin tuna and egg are 22 gram and 13 gram, and respectively. Yellowfin tuna is also rich in various important minerals that are essential for the body. With the many benefit the exist in yellowfin tuna, I think is the farming in the right choice. I think is enough.
Okay, so it will be easy for you to have a yellowfin tuna, yeah, in our country, especially Indonesia.
Okay, thank you for the answer. Is there any more question? If you do, you can raise your hand and unmute your microphone. Okay, for Aidanella, you can unmute your microphone.
Thank you for the time. My name is Aida, and I would like to ask for your research, how's your plan to implement this at the society, and how can it benefit?
Okay, for Zahrani Putri, you can answer the question.
I'm sorry before. Can you repeat the question? Before, because my signal is error.
Okay, for Aidanila, maybe you can repeat your question.
Okay, thank you. What I would like to ask is, what's your plan to implement your research to the society, and how it can give a benefit for the society? That's all. Thank you.
Okay, for Zahrani Putri, you can answer the question.
I'm sorry. May I think first?
Okay.
Okay, may I answer the question? Before that, thank you so much for the question. So the benefit of the benefits of pursuing offshore fish farming installation or offshore floating cages are opening new business opportunities and increasing employment through nursery businesses and being able to increase marine fish production. In addition, the utilization of marine space potential using offshore marine cages is very environmentally friendly because to reduce environmental impact around the offshore marine cages will be developed aquaculture by adopting the integrated multi-tropic aquaculture system so as to reduce feed and waste residues. So in addition, this system is also expected to be an attraction for fish around the offshore floating cages. Did you get the point? Did you get the point?
Okay, for Aidanila, do you get the point or maybe there is more question?
I think it's all clear. Thank you very much.
Okay, thank you. Due to the limited time, I think that's all the question from this session. So all the participants can lower their hand and mute the microphone. Thank you for Zarani Putri for your great presentation and answer. Now on to the next one with our presenter, Ahmad Amir Fadila Azudi. Ahmad Amir Fadila Azudi, the time is yours.
Yes, thanks for the time. Please open the PowerPoint. Okay, dear ladies and gentlemen, let me introduce myself. My name is Ahmad Amir Fadila Azudi. I'm from study program Occupational Health and Safety Engineering, Shipbuilding Institute of Polytechnic Surabaya. In here, I will present my research under the title Human Error Analysis on Rubber Tire Gentry Operation using CREAM method. Next. My research divided in 5 sections. The first is preliminary, the second is study of literature, and the third is research methodology, the fourth is research result, and the fifth conclusion. Next, on the first part is preliminary. Yes, PT Peti Kemas is container terminal enterprise which has high production, so must be supported by loading and unloading equipment. And one of support equipment to loading and unloading container is rubber tire gentry crane, with the total in PT Peti Kemas is 30 units and have high operation hours. So this potential for accident in the operation of RTG. And then when conduct preliminary studies, and result recapitulation of accident data in EG 2019-2021. There are 24 accidents in 2019, and there are 16 accidents in 2019, and there are 25 accidents in 2020, and there are 10 accidents in 2021. It can be seen in the diagram. They're fluctuative, and there is accident in each year from 2019 and 2021. And then conduct analyze housing LPG accidents by 3 factors: human, equipment, and environment. The generate result total and percentage based on 3 factor housing LPG accident in 2019 and 2021. From human, there is 75%, and from equipment, 20%, and from environment, 5%. So it can be seen that housing accident, the most housing LPG accident is by men, 75%. So the main cause of the accident is human error. Next. To analyze human error of operating LPG, use human reliability assessment method. And one of human reliability assessment method used in this research is cognitive reliability and error analysis method. And then generate HEP or CFP value, then provide recommendation for improvement. In this research, there are three problems. The first is how to determine the cognitive vulnerability value on LPG operation using CREAM. And second, how the analysis result of cognitive vulnerability value on Robert Hydrogen operation using CREAM. And the third is how to appropriate recommendation to reduce human error probability on laboratory GMT operations. Next. And then study of literature. HTA. HTA is, as name suggests, a hierarchical approach which describes the task from its top level goes down to the level of individual operations by Kirwan 1994. And then CREAM is technique used to assess human reliability. They aim to evaluate the likelihood of human error throughout the completion of particular tasks. CREAM's quantitative approach is divided into two stages, namely basic method and extended method by Holnikel 1998. And basic method, we are divided
Hello, or I'm Ahmad Amir. Are you connected? Okay, I think it's connected back. Okay.
Okay, I'm sorry. My connection is bad. Next. And then in the research methodology, next. In the research method, the first is early identification. They are divided into two. The first is problem identification, the second formulation of the problem, and then literature review. The first is study of literature and field study, and then data collection. There are two data. The first is primary data, and the second is secondary data. Primary data divided into the first is evaluation of expert judgment and observation, and the secondary data divided into the first is operational accident data LPG 2019 until 2021, and then rough impression of LPG operation, and then range hierarchical test analysis, and then assessing CPC, assessing CREAM. There are two-step basic method and extended method, and the basic method divided into two, and extended method divided in three stages, and then analyze CPC value, and then making recommendation and conclusion. Next. And then the result. The recent results, the first is arrange HTA. And then this is the result of HTA of RTG operation from the start until the finish of operation RTG. Next. And then assessing with cream. In basic method, they are divided in two stages. The first is assessing CTC. It can be seen on the screen. And the total of each proofs is 5 and the reduce is 0. So the result of probable control mode is strategy control. Next. And then in the extend method, they are divided in 3 stages. The first is full cognitive demand profile. In the cognitive demand profile, can be seen results the observation demand profile. There are 16.67%, and demand profile of interpretation there are 20%, and demand profile of planning there is 0%, and demand profile of execution is 63.33%. So it can be seen the highest demand profile is execution. There are 63.33%. And then in the next step is identify likely cognitive function failure. And then from the observation error, there is 0%. And from interpretation error, there are 20.83%. And from planning error, there is 0%. And execution error, there are 79.17%. So it can be seen the highest cognitive function failure is by execution error. There are 79.17%. And then in the last stage, in the extend method, is determine cognitive failure probability of RDG operation. And the result is the highest value of GFP or cognitive failure probability in subtest 3.3, 4.3, and 5.3. The value is 0.0047%. And then the next step is making recommendation due to the highest GFP of RDG operation by using CREAM method. Next slide. And then the conclusion. There are two conclusions. The first conclusion is the result of the assessment and calculation using CREAM method on the operation of RDG at PT Kemas obtained the highest HEP value in subtest 3.3, 4.3, and 5.3 with HEP or GFP value of 0.0047. And then the second, the recommendation that is given are, the first is make revision of work instruction by adding subtasks when doing gentry. And second is provide RDG refreshment to all operators and regular basis and emphasize to comply with the applicable instruction of rubber tire gentry operation at least once a year. And then the third is increase safety patrols, where the safety team is always on guard in the field and turn to monitor so that are no violation by RDG operations. Yes, I think that's all my presentations. Thanks for the attentions. And for moderators, thanks yours.
Okay, what an excellent presentation from Ahmad Amir Fadila Azudi. Now we're going to question and answer session. For all the participants who want to ask a question, you can raise your hand and unmute your microphone. Okay, there is one participant who raised their hand. For Ochi, you can unmute your microphone.
Okay, I want to ask about what's your reason to make research about rubber tire ganti operation? That's it. I hope you can answer that. Thank you.
Okay, for Ahmad Amir, you can answer the question.
Thanks for the questions. Before I answer, I have internship for in PT Petikemas, and there are support equipment, and one of support equipment, an important thing to support unloading and unloading containers is rubber tire gantry, and from the preliminary study, the result is the most thing causing for accident RTG is causing by human. So to solve the problem, I using HRA, Human Reliability Assessment, and one of HRA method which I use is CREAM method. So like that. That's all the answer for the questions. Thanks.
Okay, thank you for the answer. For Ochi, do you get the point, or is there something that you want to ask again?
Okay, that's a great answer. I appreciate and thank you.
Okay, thank you. So for all the participants, you can raise your hand and unmute your microphone if you have any more questions. Okay, due to the limited time, I think that's all question from the session. So all the participants can lower their hand and mute the microphone back. And thank you for Ahmad Amir for your great presentation and your answer. Now on to the next one. To our next presenter, it will be Anastasia Saliarelis with the title is Assessing the Effect of Falling on Ship Resistance and Fuel Consumption. Okay, for Anastasia Saliarelis, the time is yours.
Thank you very much. I have trouble sharing my screen. It says that the host has disabled screen sharing. Excuse me?
Okay, wait a second.
Yeah. Sure.
Okay, you can share your screen now.
Thank you. Okay, hello everyone. My name is Anastasis. I'm here to talk about my fourth-year project, which is about the effect of fouling on ship resistance and fuel consumption. Excuse me a second. I had some technical difficulties. Okay. Okay, so what is fouling? Fouling is the buildup of undesirable material on the ship's hull and propeller. In layman's terms, it's what you can see here in the pictures to the right, the green stuff that gets attached to the hull. Okay. So let's talk about how fouling in my project relates both to the academia and to the industry. So let's first start with the academia side of things. The results that you're going to see later on were done on a KCS hull. And why is that important? Well, because most projects use a KCS hull, and thus the results of this study are comparable to those. And for future research, it can be used as a validation study. Secondly, it's actually one of ITTC's recommendations, and more specifically the use of CFD for the study of the roughness effect on the ship's performance. But now moving a bit more to the industry side of things. First of all, the study of fouling helps in improving the ship's operational efficiency. And why is it important? Well, it's actually one of IMO's recommendations, and it helps in achieving the target of reducing greenhouse emissions by 50% by 2050. And also it enables ship owners to make a more informed decision when it comes to hull cleaning. So what has been done already? Before we move to my results, let's see what has already been done. I picked 4 papers, as you can see here, starting from the one from Song, Demirel, and Adler from 2020, in which towing tank experiments and simulations were conducted to measure the delta CT, where delta CT is the change in the total resistance coefficient. So what were the pros and cons? First of all, it did produce very interesting results in terms of how fouling affects the total resistance coefficient, but it only considered homogeneous fouling, and there was no mention of any financial impact that fouling may have. Now, moving to the second paper done by Demirel, Tunak, and Tinsesik from 2017, in which various safety simulations were also conducted to measure the change in the total resistance coefficient. Again, interesting results were produced, and furthermore, more fouling conditions were considered compared to the previous paper. But again, it had the same limitations, that it only considered homogeneous fouling, and there was no mention of any financial impact it may have. Moving now to the paper from Song and all from 2021, in which towing tank experiments were done to measure the increase in the total resistance coefficient. Again, it produced interesting results, and it also included heterogeneous fouling, unlike the other 2 papers. However, the results were done on a wiggly hull, not a KCS hull as the other 2. There was no mention any mention of the financial impact that fouling has, and because of the type of hull and the fact that only towing tank experiments were done, not simulations, the results are applicable only to model scale. And for the last paper, which outlined different methods for modeling the roughness, the benefit of that was that it helped the academia in developing more accurate papers. But the drawback was that it was too academia oriented, and this project tried to strike a balance between catering both to the academia and to the industry. So what was the aim of this project? It was to assess the impact on fouling on the ship resistance and fuel consumption under calm water. What were the objectives to achieve this aim? Firstly, it was to correctly set up the model scale ship in star CCM+, to then achieve a reliable full-scale simulation setup, and then calculate the increase in effective power of the full-scale ship under different fouling conditions. So how was this done? First of all, a model scale KCS hull without fouling was inserted into the CFD, into the star CCM+ environment, and the validation study was done comparing the CT value from the towing tank experiments from the literature with the one from the simulations to make sure that this model scale that the results of this model scale ship were indeed reliable. Then a full-scale KCS hull, then the model scale was scaled full scale, and in the same vein, a validation study was conducted, in which the CT value now of the full-scale KCS hull without fouling, the total resistance coefficient of the full-scale KCS hull without fouling on the CFD, was compared with extrapolated one from the literature from towing tank experiments. And furthermore, a verification study was also conducted to see how the CT value changes with different grid sensitivity. And after that was done, and we knew that our clean full-scale KCS hull produces reliable results, then fouling was applied. And it was applied into different regions. Here in the picture, you can see the purple region in the rudder, which is the flattened rudder region, and the green region, which is the vertical region. And the fouling conditions that were applied were both homogeneous and heterogeneous. For all cases, it was for heavy slime and wind and for 24 knots. So for homogeneous for the whole hull, heavy slime and wind, and for heterogeneous fouling, only the flattened rudder region, the purple one in the rudder, were fouled, and the vertical region was clean, and vice versa. And the CT value was measured. So putting that aside a bit, here to the right, you can see the simulation specifics for those who are really into the CFD details. So here you can see the time step, the mesh cells, and the turbulence model used. Now the results. I'm showing you again what was the aim of the paper, as to see why I grouped the results the way that I did. So the aim was to assess the impact of fouling on 1, the ship resistance, and 2, on the fuel consumption. So accordingly, the ship resistance part is the hydrodynamic aspect, And the fuel consumption part is the economic aspect of seeing how much fouling costed the ship owner. So let's first of all start with the hydrodynamic aspect. In this graph here, you can see how when each region was fouled, how much the total resistance coefficient increased by. So for example, when it was homogeneously fouled, the total resistance coefficient increased by 31% when it was with heavy slime, and 47% when it was with weir. And when we cleaned the vertical region, but we left the flattened rudder region still foul, then that increase in resistance was 23% for heavy slime compared to 31% when it was homogeneously foul, and so on. So what are some important remarks that I want you to pay attention to? Firstly, that fouling does indeed cause a significant increase in the total resistance of the ship, and that by cleaning the flattened rudder region, said increase in total resistance can be minimized. Now, a question that can maybe hear some of you asking is, why is this the case? Okay, these are the results, but why is this happening? So first of all, one of the reasons why I think this is the case is because the flattened rudder region includes a bulbous bow, and a part of the hull which we know is very effective in reducing the overall resistance that the ship experiences. And when it's fouled, it does not operate properly. And secondly, and this is in the context of this project right here, is because simply the flattened rudder region is actually larger than the vertical region. So moving from the hydrodynamic aspect a bit to the economic aspect and seeing how much this costs the ship owner. Here you can see the cost of extra fuel consumed due to fouling for heavy slime and weir, in which we assume the 180 days of operation and the fuel price to be $530 per ton. So how was this done? We compared I compared the total resistance that the ship experiences in its fouling case compared to when it was clean. And from that, with some mathematical manipulation, I was able to find the fuel consumption. Now, as you can see, again, homogeneous fouling is the worst of them all. If you remember a bit earlier, I told you how the one region is larger than the other, and that contributes to the one region being more effective. Well, that is true, but even adjusting for that, as you can see in this graph right here, still the flattened rudder region proved to be more successful if you clean it. So, with that in mind, these are the post-mortem observations that I want you to see from this slide. First of all, that similar to the resistance results, fouling does cause a significant decrease in the fuel consumption. Secondly, that by cleaning the flattened rudder region, said increase in the fuel consumption can be significantly decreased, and that even adjusting for the fact that the flattened rudder region was larger, than the vertical region, it still proved to be a more effective region to clean. And so in summary, what this paper was able to produce was you can see in the table right here all the figures, the force, the fuel amount, and the key takeaways are that homogeneous fouling can increase overall resistance of the ship by 30% or more, while impacting also the fuel consumption and up to $4.33 million, and that the flattened region proved to be the most successful region in reducing the resistance in fuel consumption originating from fouling. Thank you. These are the references. Thank you very much. Are there any questions?
Okay, what an excellent presentation from Anastasis. Now we're going to question and answer session. For all the participants who want to ask a question, you can raise your hand and unmute your microphone.
So I assume it was that good, huh? No questions. I'm glad.
Excuse me, I have a question.
Hi.
Maybe the question is almost the same with the previous. That's about some of the challenges that you face and then how to overcome the challenge. Of course, in doing research, I'm sure there must have such kind of challenge, and then how to solve or how to overcome the challenge during conducting this research.
So there are a lot of things, but I'm just going to say one which you can also see here. So one problem was actually creating the regions, to the flattened adder region and the vertical region. If I zoom in to this picture right here, do you see how the purple region here is a bit curvy? Like it's like this, it goes up, it goes down, and then up, and then up again. So this was like a compromise on how to be able to produce some results. In that, a problem was that it wasn't very easy for me with the time constraints that I have to define the regions very well. So what I ended up doing was I tried to roughly create the regions and to be able to produce the results that I showed to you before. So that was one compromise and challenge that I had to overcome, and the decision that I had to take. And one other one, which is a bit more technical, is actually scaling up to full scale, and that this takes time, and was done in the context of my 4th-year project. And to that, the only solution is the old classic time management, but I can't give you anything more than that.
Okay, well, thank you so much for the answer.
No worries, I'm glad to help.
What a great answer from Anastasis. So, for other participants, if you have any more questions, you can raise your hand and unmute your microphone. Okay, for Aidanila, you can unmute your microphone.
Okay, thank you for the time. I would like to ask, so based on the result of your research, if you want to develop this result of this research, what do you think the most important thing that you can explore more? That's all, thank you.
Yeah. So one aspect that I wanted to do, but I didn't have the time, and I would recommend future researchers to try to pursue, is actually splitting, except from making the flattened adder region more defined making more defined, is actually splitting it longitudinally as well. So let's say you have the aft part of the flattened adder region, you have from to the midship, and you have the forward part. And see, for example, if the bulbous bow is not fouled, but if the rest of it is, to see how again this plays into the whole fuel consumption and total resistance. Because speaking with some people from the industry, the common practice actually is to clean the rudder and the first 30% of the bottom region. So that would be an interesting thing to see how the bulbous bow affects the effectiveness of the flattened adder region, and this can be done by separating from the rest of it.
Okay, for Aidanila, is it answer your question?
Yeah, it is clear enough. This is such a great presentation. Thank you so much.
Thank you.
Okay, I think that is the last question for this session due to our limited time. So all participants can lower their hand and mute their microphone back. Thank you, Anastasis, for your great presentation and answer.
Thank you for having me. Have a great day.
You too. Now move on to the next presenter. Is from Ali Hasimu with the title Investigation of Automated Welding Technology on Ship Panel Construction Using Simulation Approach. So for Ali Hasimu, the time is yours.
Thank you very much, moderator. Can you allow me to share my screen?
Okay, you can share your screen now.
Can you see my screen?
Yes.
Okay, thank you very much. Yeah, my name is Ali Hashim Hussein. I'm a student from University of Australia. I'm studying Bachelor of Science, a Master of Science in Advanced Naval Architecture. So today I'm going to present about investigation of automated welding technology during a ship panel construction using simulation approach. So my presentation will be in 9 parts, and I will cover introduction, then methodology, a case study, data analysis, results, thereafter discussion of results, conclusion, limitation, and finally, I will put a future recommendation for further studies to be conducted. So starting with the introduction, we are all aware that now many shipyards experience problems of project delay and cost overrun. So increasing productivity and operation efficiency will help shipyards to make technological transition necessary for designing green shipyards. So in my research, I tried to investigate the effect of semi-automated gas manual arc welding and full automated manual arc welding to see their effect in terms of time and cost. So the motive for this study was first, to improve the performance in the shipyard. So what we expect from that is a profitability of the shipyard and certification of ship owner, and all of this will be achieved after enhancing the process of panel line construction process. So I decided to focus on panel line construction process because we are all aware that in a modern shipbuilding, we are using blocks, and several blocks are joined together to the entire shipyard. So many attempts, many research has been done on optimization of ship blocks, but they ignore this panel line construction, which is a significant part of the ship block. So the aim of this research was to start. The aim of this study was to improve the welding process during the ship panel manufacturing by adding automated welding technology, and specific objective was to develop the panel line construction model. The second one was to investigate the effect of utilizing automated welding technology in the shipyard. The third one was to enhance the throughput of the shipyard. And lastly was to minimize the cost and time incurred during the ship panel construction process. So in more detail, the following research question will be addressed in more detail. Can automated welding technology reduce the processing time and lower the cost during the ship panel manufacturing? So in accomplishing this study, the following methodology was adopted, and my methodology was comprised of 10 steps. So in summary, the first step was to define all process involved during the ship panel line manufacturing. The second one was to develop 2 different models using arena simulation software by using a discrete event simulation. So one model was for the whole process of ship panel procedures involved during the ship panel manufacturing. And the second model was only for welding processes. So the third step was to simulate the model to determine the system actual performance using comparing the data that I have obtained from the shipyard. Thereafter was to suggest the potential changes for the new welding technology to the current models. So as I said before, the new potential changes, especially in welding technology, was semi-automated gas manual arc welding and full automated gas manual arc welding. So those are technologies that were proposed to replace manual arc welding, which is used by the shipyard currently. Thereafter, obtaining the final result. And finally, I compared the result which I obtained from original model and the result I obtained after incorporating the new technology in the new model. So from the methodology adopted, I used the 2 methods for data collection. One was direct field observation in a shipyard, and second one was desktop studies. But for desktop studies, most of data were obtained from various resources such as from codes, welding codes, from the standards, from manuals, from journals, and other data, especially for cost, was obtained from the suppliers. For instance, gas for a cost for the gas which is used in welding. So
My case study was involved a straight panel line, and this panel line, it comprises of 12 different plates, and each plate were given a certain number for easy identification, and total number of plates were 15. So in general, 15 plates were used to manufacture a single straight panel line. So in development of model, actually in ARENA simulation software, there is a various modules that to be used during the development of model. So depending on your case, but you can use different modules. But in my case, I used only 6 fundamental modules. One was a create module, and this module was used so as, to show the start of flow of my entities during the simulation. Also, I used assign module that was used only to define a simulation parameter. Thereafter, I used the process module, and process module was used to define the various processes which are involved during a chip panel manufacturing. Then I used the batch module. A batch module was used, to represent combining different entities together, like assembling procedures. Then I used the decide module. That decide module was used, for decision making, moving my entities into various working stations. Then finally, I used the dispose module, and this module was used to show the end of the simulation of end of my entities. So as you can see here, these are creative modules that were used for each plate, and at the end, all my entities were flow through variance process, and finally, dispose module were used here to represent the end of my simulation. So in my case, I used 2 different models. This model was for the whole process of panel line manufacturing, and this model was used only to define the welding procedures. So for the case of cost, I used this model, to have a total cost of the whole system. But for the case of time, I used this model, especially for the welding procedures, because my investigation was to investigate the effect in cost and time. So unfortunately, in this model, many process during chip panel is not dominated very much with the welding processes. So that's why I decided to use a separate model. So in data analysis, one of the challenge that I faced, the lack of relevant data, especially for cost of welding deposit. So I decided to develop a custom Excel sheet to estimate the cost per hour and cost per millimeter for each method, and all parameter which I have used, I was to make sure that a minimum fabrication limit of the weld will be achieved. So as you can see here, for instance, in case of gas manual arc welding for semi-automated, the cost per hour calculated was around $21 per hour, and cost per millimeter was $0.0006. So various parameters were used, and those parameters most for consumables, especially for filler materials and labor plus overhead cost and the cost of electricity. So this is another Excel sheet, and this Excel sheet was for gas manual arc welding for semi-automated. As you can see here, the final value obtained is quite very small compared to for semi-automated gas manual arc welding. So that was an analysis based on cost, but analysis based on time, as you can see here in table number 2, it show triangular distribution for the time. But for instance, for the manual metal arc welding, these values, these numbers were obtained directly from the shipyard. So in triangular distribution, normally we use minimum time most strike time and maximum time. But for triangular distribution for semi-automated and full automated gas manual arc welding, this value were calculated from based on data collected and the value of the speed. So for the case of also, I mean, average speed for the manual arc welding, this was estimated in a shipyard, and this was this value was obtained by considering the, I mean, welding distance and total welding time. So unfortunately, we didn't use a specific measuring instrument, but we tried to, I mean, to estimate the value of speed for manual metal arc welding. So these are results which were obtained, and these results were obtained after performing 100 iterations in our model. So as you can see here, these are results for the cost. So for instance, in manual metal arc welding, the total cost for the whole system was obtained to do around $1,131, but for semi-automated it was around 919, and for full automated was 916. Of course, as you can see, it is clear that the costs tend to reduce as you are shifting from manual metal arc welding to the full automated. But from semi-automated to full automated, of course, these results were unexpected, because we expect maybe when you shift from semi-automated to full automated, the cost would be a half of semi-automated. So it's clear that from the table, the reduction in cost was possible. That's because of reducing in idle costs. Normally, idle cost is a cost that incurred when resources are scheduled but are not in use, and busy cost is a cost that's incurred when resources are scheduled and in use. So from these results, it tells us this automated or semi-automated welding, actually they have a great impact in reducing the idle cost. So overall, so by substituting manual metal arc welding with semi-automated, probably 28% reduction in cost can be achieved, and 0.37, which is very slight, very small reduction in cost, was observed after shifting from semi-automated and full automated gas manual arc welding. As I said before, these results were unexpected, and this is because I have obtained this result because of the calculated value for the cost per hour, which I calculated using a custom Excel sheet, which I presented before. But for the case of time, actually, I obtained a very promising results. So as you can see here, for instance, 65% reduction in welding time was achieved after after shifting from manual welding to semi-automated welding, and further reduction up to 70% was achieved after complete shifting from manual to the full automated welding. So these results they indicate indirect proportionality. As you increase arc travel speed, as welding speed increase, probably the welding time will tend to decrease, and that is we can appreciate with what robots they do. So in discussion, in summary, I can say results obtained when shipyard uses semi-automated and full automatic gas manual arc welding during ship panel manufacturing demonstrate significant cost and time saving. So this was the aim of this research. So I can say from the results which I have presented before, it's clear that cost and time were reduced from shifting from manual arc welding to automated and semi-automated. So I can say findings agree with the primary goal of reducing panel line manufacturing time, while simultaneously lowering overall manufacturing costs through increased productivity. So in conclusion, so to conclude, I can say that due to, increase in ship tonnage, requirement for the more ships to be constructed, and actually we can see now demand for more ships is keep on increasing worldwide. This is due to imbalance in resources, like imbalance in resources from the where produced to the where to be consumed. So it is clear that faster and more effective welding procedures must be developed to fulfill the rising demand in worldwide market for shipbuilding tonnage as it keep on increases. Also, robotic welding technology are expected to increase its throughput at shipyard and significantly increase their competitiveness in shipbuilding industry. Of course, this is clear we can appreciate this. For instance, in China and Korea, of course, I think the one who use this automated welding technology is effective. So we can see they able to produce many number of ships, especially when it comes to ready products of ships. Most of ships are constructed in Korean ship, and most of shipyard there they use automated welding technology, which are developed in-house. Also, another advantage which can be achieved when shifting to using robots, especially in robotic welding technology, is reduction in carbon dioxide emission due to low input energy which is needed by robots. So in conclusion, I can say, so this robotic welding, they tend to minimize errors which are caused by human mistake. And these errors are minimized because welding robots are very safer, less costly, and more accessible. So despite of what achievement which I have obtained in this research, still there are some limitations. One of the limitation is transportation time of entities from one workstation to another was not gathered or not incorporated in the model. As you can see in my model, I assumed the whole process of manufacturing ship panel is a continuous process, which is unrealistic, especially when it comes to a real shipyard environment, because there is a time for break. Sometimes there's a time waiting for supply of materials. So another limitation is man welding speed at shipyard was not appropriately measured using a proper instrument, as I said before. Another limitation was a shortage of time to acquire more data from the shipyard. The investigation of welding procedure on time was done independently. Yeah, of course, to get a good result or fruitful result of this research, probably if you are going to investigate on, let's say, on ship broke or on entire hull or in any process during a ship manufacturing which involve in which a welding process dominates, probably you can have a good result. So because as we all know, process of constructing, let's say, of manufacturing block, it takes very high time. So due to that, I focused on ship panel. Lastly, the new welding technology expenses such as a capital, operation, and maintenance costs were not considered to replace manual metal arc welding. Of course, here, this semi-automated gas manual arc welding and full automated arc welding were suggested, but the cost of capital cost of investment, it is operational cost and maintenance costs were not considered in this research. So based on those listed limitations, so the following are recommendations for the future investigation, for the future study, which can be conducted on this topic. First, the future study should be include transportation time of entities during the processing may be included in the model. So in a future research, if you include transportation time, probably the new model can be developed based on route and station. Also, future study can be expanded to more than one panel line or block construction, or joining the blocks to the entire ship hull. The third recommendation, I recommend the future study can use waist-mounted accelerometer, to estimate the manual welding speed. And in this case, I think human performance, especially skills of welder, should be taken into consideration, so as to have a good value of manual welding speed when you are estimating it or when you are measuring it. Also, a future study may investigate the effect of laser cutting and laser hybrid welding processes. We all know that laser cutting is very high developed technology, and laser hybrid welding process also is very high developed technology when it's come to welding. And it, for instance, this laser hybrid welding process is quite used very much in automotive sectors. Future study also, financial analysis can be conducted, especially in capital expenditure, so as to calculate the return on investment, so that when it's come for making decision for managers, so if you are, what will be the return of investment in investing in the robotic technology, probably it can convince decision makers to make a decision in investing in robotic welding technology, especially in shipbuilding. Also, a future study may examine the capital, operating, maintenance, and additional costs for proposed welding technology. Another recommendation, a feasibility study of proposed automated welding technology is be conducted first. So, a future research feasibility study of the proposed automated welding technology can be conducted before investigating it. And lastly, the procedure for optimization can be applied and strategy may be modified and enhanced in several ways. For instance, after investigating the effect of this robotics or automated welding technology, probably one can decide to adopt optimization procedure on final models, like see what will be the effect after, let's say, using resources in different capacities. So thank you very much for listening and your attention. So you are most welcome for any question you have. I'll be happy to address it. Thank you very much.
Okay, thank you so much for the presentation. What a great presentation. Because the limited of time, probably I only can, there's only one question probably for this session, because limited of time. So for all the participants who want to ask, you can raise your hand and unmute your microphone. Okay, for Rosa, you can unmute your microphone.
Okay, thank you for the time. So based on the diagram that show on the slide, there is a result from manual to automatic is significantly different. And how long did it take to investigate in this research? And what's the, but how's the result of the welding between manual and automatic? Thank you.
Okay. For the time, it's taken me around more than 6 months to investigate this. And the second question is you asked what's the difference between manual and automated. Am I correct?
Yeah, yes.
Yeah. Of course, in manual process or manual welding, it involves human. A welder is the one who performs the wood processes. But in automated welding process, probably it involves a machine, a robot. So a robot, you'll have a device which can do the wood process, but it will require human supervision. But the wood process will be done by using robots. But in manual, probably a welder or human being is the one who is responsible to do everything.
Yeah, but in robots, probably the whole process will be done by machine. Yeah.
Okay, thank you for the answer. And I would like to ask one more thing again. What I mean is there any quality differences between the welding result of manual and automatic?
Yeah, of course, there is a very high much difference because robotic welding technology, they produce very high quality of the weld compared to manual welding process, because manual welding process, it will depend on skills of the welders. But in robotic welding process, if you know all parameters which will affect your your final qualities that you want to achieve, probably using robots, you can set all parameters as required and you'll get the final results. But for the manual welding, probably it will depend on skills of the welder. So for instance, if you want to achieve high quality of weld, probably you need a welder with very high skills and capabilities. And sometimes that's will be sometimes that's very, very challenging because skilled welders are very few worldwide. So that's why, as we can see in the automotive industry, for instance, they able to produce very high quality of the welds, and the welds which are produced can exist for a long time with the high strength and can work in as required. Yeah. So absolutely. Quality for the robotic welding technology is very, very good and is very high compared to manual arc welding. That's why I have tried to investigate the effect of this technology, so that to convince shipyards, especially in shipbuilding sector, to shift and starting to use robotic welding technologies, because not many shipyards are using manual welding process.
Okay, I think it's very clear. Thank you so much.
Okay, I think that's all the question from this session. So all participants can lower their hand and mute the microphone. Thank you, Ali.
Oh,
for your
and sorry for using more time. So sorry for that. Yeah, sorry for that. Okay, thank you.
Yeah, it's okay. Thank you.
Oh.
Now to the next presenter. It will be Sofia Rahmania Wardah, with the title is Design and Fabrication Solar Cell and Micro Hydro Power Plant with Remote Monitoring System. So for Sofia Rahmania, the time is yours.
Okay, thank you for the time. Good evening, everyone. Standing in front of you today, I would like to introduce myself first. Hello, my name is Sofia Rahmania Wardah, with the second author is Mr. George Andri Kusuma. Today, I would like to present about my research with the title is Design and Fabrication Solar Cell and Pico Hydro Power Plant with Remote Monitoring System. Next. Okay, next. Okay, we know that 100 million people live in Indonesia and electrical energy is the primary need for the community to carry out their daily needs. However, currently energy is a global issue that must be faced. This happens because an imbalance between the energy demand and the availability. And another issue that happens in Indonesia is about climate change. Next. So it is time for Indonesia to make a transition for using a renewable energy to depends on fossil. So based on Secretariat General National Energy Council 2021, Indonesia has a large potential of renewable energy such as solar energy and hydropower. Next. And in this research, I'm using Ulrich method. Next. Next. And the result are I made this design screw turbine using Autodesk Fusion 360, and the detailed component consists of first is frame, second is spindle, third is housing, fourth is water collector, fifth is pulley and belt, 6 is generator. And the calculation is based on research by Chris Rores. And the parameter that I'm already calculate, the length of turbine is 80 centimeter, diameter of screw outer is 24 centimeter, diameter of screw inner is 12 centimeter, the thickness of blade is 0.2 centimeter, distance of screw is 19 centimeter, total of screw blade is 1 pieces, total of screw coil is 4 pieces, and the total dimension of the screw turbine is 900 times 344 times 320 millimeter. Next. And after I made the screw turbine design concept, the next step, I made the top component design. And here is the first design concept that I have already made. And the cross-sectional area I'm using is rectangular. The total component is 4. Next. And the next is second design concept. Next. Okay, the difference between the first design concept, the cross-sectional area that I'm using is hexagon. So the total component is 8 pieces. Next. And next, this is the third design concept. The difference between the first and the second, the cross-sectional area is using circle. So the total component is 6. Next. And after I made 1 until 3rd design concept, the next step is doing concept selection using Ulrich method. So I make a concept assessment matrix with the criteria consists of 3, such as fabrication 25%, portability 35%, cost estimation is 40%. So if we total, the percentage is 100%. And then I'm calculate between the rate and the percentage from first, second, third until the reference design concept. Next. And we can see from this slide that the first design concept got a higher score than the others. So the first design concept can continue to the next step. Next. After we got the first design concept, the next pass is doing a fabrication to make this product. And to make this product is consists for each step. Like first is doing blade manufacturing, second shaft manufacturing, third is assembly blade and manshaft, fourth housing manufacturing, fifth is make a frame, sixth make a water collector, 7 is make the top component, and the last is assembly all the component and also doing a coating. Next. And this is the product mechanism. So first, the solar cell will absorb the sunlight and the screw turbine will convert the kinetic energy into an electrical energy. And after that, the output will direct into the protection box because the voltage still unstable. After from the protection box, the voltage will direct into solar cell SCC and generator SCC to decrease the voltage into 12 volt. After that, the voltage will direct into the battery and then direct into the power inverter to convert from DC current into an AC current. And also in power inverter, the voltage will increase and then the community or the social can utilize this electricity for lighting or for charging the smartphone. Next. And then after the product already made, the next step I'm doing performance test on Mentaraman Strait in Malang region on East Java with the specification from the irrigation canal is the width is 1000 millimeter, the depth is 500 millimeter, average velocity is 1.28 meter per second. Next. And you can see on the right side, this is the documentation when I'm doing a performance test, and the result from DC generator, this product can produce average power is 29.1 watt. Next. And then from the solar cell can produce the average power is 24.95 watt. So if we combine between the solar cell and the generator, this product can produce for 54 watt. And from this output, this product can utilize for lighting or maybe for charging the smartphone. And you can see on the right side, this is the documentation from the performance test. I'm doing testing with LED lamp, 9 watt. Next. And one of the advantage from this research, the people or the operator can monitoring by remote just only in website integration. So the people can visit our website on www.hybridgenerator.xyz or just scan this QR code. So people can monitoring the output from the frequency, the ampere, and the voltage. Next. And the cost needed to make this product is 9,534,284 rupiah. Next. And the conclusion from this research, first, the total dimension of this product are 900 millimeter times 600 millimeter times 1,320 millimeter, and the fabrication process that needed to make this product consists of 8 steps, and the total cost required to make this product is more than 9 million rupiah. Next. And here are some my reference. Next. And we already on the end slide. I think that's all from me. I would say thank you, and it always seems impossible until it's done. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. What an excellent presentation from Sophia Rahmania. Now we're going to question and answer session. For all the participants who want to ask a question, you can raise your hand and unmute your microphone. Okay, for Rosa, you can unmute your microphone.
Okay, thank you for the time. I would like to ask, at the slide, you already show that you already try to implement this product. And so what do you think this product can make the significant change to community and the environment? Thank you.
Okay, thank you for the question from Rosa. I think maybe the people beside the irrigation canal or the rice field can protect their irrigation canal without throw the rubbish into the irrigation canal. So the irrigation canal will still clean and also clear from the rubbish.
Okay, thank you for the answer. I think this is such a great presentation. Thank you.
Okay, thank you for the answer and for the question too. Now, is there any more question from the participant? You can raise your hand and unmute your microphone. Okay, I want to ask for Sophia Rahmania. There is 3 design concept, and what's the factor to determine which design that we need to use?
Okay, thank you for the question. Maybe the moderator can move to the 7th slide. Okay, we can see on this slide. I determined this concept based on wait. Okay. I'm determined the first, second, and third design concept is based on the maximum stress that that products from each design concept. Like in this first design concept, the maximum stress is 4.251 MPa. And I'm compared between the first, second, and the third, what the maximum stress that suitable if I'm doing stress analysis from the software. And after that, I'm compare the cost estimation, because if the cost estimation is too pricey, I think the community or the people is being being hesitant to choose what the innovation in renewable energy, because the goals I meet this product is make the product with low price, and the community or people can access the electricity with a low price, or maybe can free to access the electricity, and can give many advantage and give many utilize for the people. I think that's all, Ajeng.
Okay, what a great answer. Thank you so much for the answer. Now, is there any more question from all the participants? Okay, is there any more question? If there's none, okay, I think that's all the question from this session. So all the participants can lower their hand and mute the microphone. Thank you, Sophia, for your great presentation and answer.
Okay,
Now
thank you.
to the last presenter from Alfie Sanantika, with the title is Probability Analysis of Human Error on Container Crane Operation using SPARH method. For Alfie Sanantika, the time is yours.
Okay. Can you hear my voice clearly?
Yes, I can hear you clearly.
Okay. Thank you for the time. Dear ladies and gentlemen, my name is Alfie Shanantika from Study Program of Safety Engineering 2018, Shipbuilding Institute of Polytechnic, Surabaya. In this very good occasion, I would like to thank for the opportunity that has given to me. It is an honor for me to present our research paper in this International Student Conference 2022. I'd like to present our research paper entitled Probability Analysis of Human Error on Container Crane Operation using SPARH method. Next slide. This presentation consists of 4 chapters. The first chapter is introduction, the second is methods, and then result and discussion, and the last is conclusion. Next. Next slide. Okay. The first is introduction. Most of logistic activity in Indonesia are carried out by 25 ports located in 21 provinces in Indonesia. The Container Service Company is one of the companies that carry out the logistic activity by providing the container terminal facilities. Based on Indonesian Central Statistic Agency, there was increase in loading and unloading activities of shipping both domestically and abroad in 2005 to 2019, which this effect on the use of the loading and unloading tool used by Container Service Company, namely container crane. Container crane is the main tool of the company that they use in the dock of the company. These tools are used for loading and unloading activity from ship to the dock, and so from dock to the ship. So this certainly has a high potential hazard that will cause the work accident. And then based on accident data in 2018 to 2020, container crane operation has the highest accident work rate of 42%. And then conduct the preliminary study. The biggest causing factor of accident work on container crane operation is due to human error. So it is necessary to do analysis using SPAR-H method to analyze the probability of human error on container crane operation work. The next slide. The methods used in this research is SPAR-H method with compiling hierarchical task analysis first. Hierarchical task analysis is relationship with work equipment in the work process. It created based on work instruction and then the condition that exists in the field when the work process of container crane is carried out. And the data processing will be carried out by SPAR-H method. The first step is diagnosis and action activities, and then determining performance shaping factor by expert judgment. Performance shaping factor has 8 factors, namely time availability, it has 6 terms, and then stress, it has 4 terms, and then complexity, it has 5 terms, and then experience or training, it has 4 terms, and then Q, it has 6 terms, and ergonomic, it has 5 terms. Then fitness for Jati, it has 4 terms. And the last is performance shaping factor of work process, it has 4 terms. After determining the value of performance shaping factor, it can calculate the human error probability value. And then the last is determining dependency factor. Dependency factor has 4 factors, namely crew, whether it's same crew or different crew, and then time, whether the distance for working stage 1 and 2 is close or not close, and then location, whether the location for carrying out the work process is same or different, and then the queue for the work process is available or not available. And for dependency factor has 4 criteria, namely complete, high, moderate, and low. Next slide. For result and discussion, hierarchical task analysis of container crane operation work has 6 main tasks. Task 1 is general operator preparation. It consists of 4 subtasks. And then task 2 is operator's preparation before operation. It consists of 9 subtasks. And then task 3 is unloading and loading container. It consists of 12 subtasks. Task 4 is chain removement. It consists of 6 subtasks. And then task 5 is open or close activity of hatch cover. It consists of 6 subtasks. And then task 6 is container crane operation completion. It consists of 3 subtasks. And then data processing will be carried out by SPAR-H method. The first step is determining diagnosis and action activities. Container crane operation work is diagnosis and action activity. It's said to be diagnosis activity because it depends on experience and knowledge of operators to planning and determining appropriate movements such as hoist up or hoist down or chain and pump up or pump down. And it's said to be action activity because besides it depends on knowledge and experience of operators. It uses the written instruction, namely work instruction of container crane operation work. And the next step is the value of performance shaping factor. After determining the performance shaping factor, the next, it can calculate the human error probability value for each stage of container crane operation work. There are 5 variation value. There are 0.315, 0.043, 0.101, 0.011, and 0.022. And the highest value is 0.315, where all the highest human error value are in the container crane operation work. Next slide. The last step is determining dependency factor. For container crane operation work, there are two criteria: dependency, complete and high, with the value of complete of 1, and the value high dependency is 0.505. Next slide. Conclusion. The result of determining the probability value of human error using SPAR-H method obtained 5 variation value where the highest value is 0.315. This is found in 5 stages of container crane operation work. Meanwhile, the lowest human error probability value is found in the most of preparation and completion stage of container crane operation work with a value of 0.011. And the value of dependency factor on container crane operation work obtained 2 criteria of dependency, namely complete with a value of 1 and high with a value of 0.505. High dependency criteria are obtained in subtask 1.4 and subtask 2.1 because one of the criteria, there is location between stage before and after is different. But for the worker time and queue has the same criteria as other stage. To prevent accident due to human error, the company can held the refresher training for operators according to the law number 1, 1970, chapter 9. Okay, next. That's all my presentation. Hopefully it can be useful for us. Thank you for watching and the nice attention. Thank you.
Okay, thank you so much. What an excellent presentation from Alfie. Now we're going to question and answer session. For all the participants who want to ask a question, you can raise your hand and unmute your microphone. Okay, for Rosa, you can unmute your microphone.
Okay, thank you for the time. Actually, I have 2 questions. The first one is there is any specific reason why your research using SPAR-H method despite of all other methods? And then the second is, what's your best recommendation to reduce hazard from human error on container crane operator based on the result of your research? That's all. Thank you.
Okay, for Alfie, you can answer the question.
Okay, thank you for the question. Why I choose SPAR-H as my method in this research? Because the 8 performance shaping factor have the match with the container crane operation work. There are example for the queue. The queue in the container crane operation work, there is available for container crane operation work for operators. And the next example is for economic. Economic is the interaction for human and a tool environment. And in container crane operation work, there are interaction between operators, container crane tool, and then the environment in the top of the company. And then for the next question, the recommendation. I think the recommendation that suitable to reduce the human error on container crane operation work, especially for operators, the company can help the refresher training for improve the performance of operators. I choose this recommendation according to the law number 1, 1970, chapter 9. And I think with the refresher training, company the company uh, can see how performance of operators are. Thank you.
Okay, thank you for the answer. For Rosa, is it answer your question?
I think it's clear enough. Thank you.
Okay. Okay, because the limited of time, I think that's the last question for this session. So all the participants can lower their hand and mute the microphone. Thank you, Ovin, for your great presentation and answer. Wow, what a great presentation of an excellent paper from our 15 speakers, both from Shubiding Institute of Polytechnic Surabaya and University of Starklight. I hope that after listening to all the presentation from these great students, we all get valuable knowledge that we can later apply in our real life. And that brings us to the end of the session. Thank you so much for your time and attention. I'm Ajeng Puspaning Tias, signing out. I'm giving it back to Aura.
Okay, thank you, Ajeng, to take the lead of our amazing presentation. So it's our moderator. Okay, now we will have a break for 5 minutes. For all the participants, please stay and still be here because after this, we have the most expected session for all participants. Thank you. Okay, ladies and gentlemen, now we already come back into our conference. Please make sure that your camera is already open and put your microphone off as we continue our session. And I would like to inform that the presenters from University of Strathclyde, PPNS will prepare Indonesian souvenir that will be given in November during PPNS visit to University of Strathclyde. Now we move on to the last agenda, which is the most exciting session. As you can guess, it is the time to rewards conference announcement. Please allow me to read the best presenter from PPNS only. And the fourth place is congratulations, the best presenter number 4 goes to Alvina Putri Aulia. And the second runner-up is the best presenter number 3 goes to Alvi Shanantika. Congratulations for Alvi Shanantika that become the second runner-up of our best presenter. And the first runner-up goes to congratulations to Della Amalia on your hard work for your papers. And the lucky one, which is the winner of our best presentation, is the best presenter number 1 was Sophia. Congratulations for your achievement. You are our best presenter for today. And the most active and lucky participant, we will contact you to deliver the reward. Congratulations and thank you for joining us.
Congratulations to Aida, Nela, Rosa.
Wow. Congrats for you to get the reward. You guys are amazing and the other are marvelous too. Finally, we would like to thank our distinguished speakers and speakers who shared their valuable insight and experiences. We hope you enjoy our conference and may this conference build up our understanding about the problems of maritime sector and enhance the sustainable of ocean-based resort to innovation on maritime technology. I'm Radishan Zinga, Master of Ceremony.
Alvina Zahrani Sofia.
To each and every one of you for attending this International Student Conference or ISC 2022. Please enjoy the rest of the evening. Once again, thank you. Wassalamualaikum warahmatullahi wabarakatuh.